can start to transmit to YouTube, Cristiano. And now you are live and starting the workshop in 10 minutes. Because you have now, there is also Tomoyuki. Just to stop. Okay. Just to see. I have some place that is. It's here. I have a lot of places running the video. So, Tomoyuki.
Oh, hello.
Hello, nice to see you. Thank you for coming.
Yeah.
Great. So now you have how many concurrent viewers too? Okay. And Cristiano, you are prepared for opening? For sharing? The first session and opening? Your microphone is closed, Cristiano.
Testing the verb.
Not super.
I think it's fine. Can you hear me, right?
Yes, perfectly.
Can you hear them?
I don't think they can hear me.
No, and you should be hearing them too.
Can you hear me?
Terrible. Your microphone is terrible.
I don't hear them. How come the speaker isn't working?
Yeah, I turned it off because
I don't know if it's switching on. Yeah, I turn off light.
It's very noisy. Very noisy.
How about now? Still worst?
Bad.
Okay, so this here.
I don't know why it's super noisy.
What about now?
Now it's perfect.
Okay. Now it's just a matter of volume.
Okay. Now it's perfect.
Okay, good. Perfect.
So, ready to go?
You.
I coffee them. Oh, by the way, let me do something very cool. Should I show you this?
I'm super happy that you are here, guys, and Hayana, super cool. Sometimes it's you are a small community that you're trying to grow up around this topic in automation and games. That's super happy. I imagine that you are this passion too about games, so that's why you are preparing this conference with care. But we are discussion with Paolo too about this point, why this is hybrid, this is remote yet. But I think during the workshop, you can discuss also your preferences and the possibilities for the next year. Maybe have something more hybrid that we can participate in person too, if it's possible. Because you have to prepare your papers for the next year too. If you are here, you continue. Because this is honestly, you try to do as a real true workshop, is something for us, something to put together people that would like to work in this topic. It's absolutely friendly. So it's for you, it's for us. So you have our Discords to discuss, and this Discord is something that you can continue to use. You are welcome. It's not my Discord, it's not Cristiano's Discord. You can create as a community Discord. So the previous participants continue in the chat. They are welcome to. So it's a movement that you can continue to grow up for the time. You are also welcome to collaborate as organizers, and you are to create this community. And you are able to share your screen, Cristiano. It's okay for you?
Yes, I'm gonna try. I think you're okay, right? Yeah.
Perfect.
Is the live streaming happening already?
Yeah. And
Let me check.
Cristiano, there is a microphone.
No, it works.
Because you can listen, Jan,
You can sit
by the
side by side.
Cristiano's microphone.
I think we have a better setup than Paris. But don't tell him.
We have a very nice setup here.
We have a better setup than you, Fabio.
Yes, absolutely.
Sorry.
Yes, one stuff that I have to do is put you as a co-host.
But we don't have any console to play. But
Oh, did you see what I put in my list of devices to buy with my CFI?
no,
You didn't see?
I put some video games. Right?
Yeah, I saw that you put this. What was the name again? This console. But anyway.
Hello.
Perfect, Cristiano.
I think I'm gonna check.
2 minutes, you start.
2 minutes. We.
But Hayana and Tomoyuki and Kazuki, did you receive the proceedings correctly?
Yes, I had.
Okay, great. If you just to confirm that your paper is well in the proceedings, if it's all right. If not, you can have some time to correct.
Good.
You're live on YouTube too.
Oh, you are there.
Yes, you are live. Hi, everyone from YouTube.
Don't see us, right?
They see in the corner, yes.
Oh, okay, I see. Okay. But they don't see that view with all the participants.
No, just the main one.
Then the one who speaks.
Yeah, they saw this basically.
Yeah, okay.
People here are privileged as participants to chat and have a Zoom. That's a privilege, but everyone in YouTube is welcome.
I don't think there's no one to comment.
No one is coming today.
So let's start, Cristiano.
Thanksgiving today.
Thanksgiving.
Thank you, by the way.
Yeah, thank you.
Thank you, everyone.
Thank you, everyone, to be here. Thanksgiving.
Can we start, Fabio? Or
Yeah,
should we wait a little bit more?
Let's start. It's 9 a.m. Time to start. Hi, Ellen.
Oh, can you?
Hello.
Hello. Can we? Should we start or wait a little bit?
I think you can start. 9.
Okay.
It's 9.
Okay. 9 a.m. on a Thanksgiving. thank you very much for coming today. I would like to present, I'm very proud to present the ASE4Games 2022. The workshop is the second workshop, international workshop, together with the ASC conference on automated software engineering for games. My name is Cristiano Politovski. I'm here with Jan Gelgenek, professor, and Professor Fabio, also through Zoom. We are also on YouTube, live on YouTube. You can share the YouTube link to everyone. And we are here in Zoom with the participants that are going to present the paper and also the keynote. So first, we'd like to thank you very much for attending the workshop, for helping us to organize it. And you know that is very a lot of work to organize an event like this, although it's very small, very comfy workshop. But thank you very much for attending and helping us. I hope you are here with us next year as well. So I present myself already and the professor. So I'm a postdoc at ETS, École de Technologie Supérieure, here in Montreal. Jan is also a full professor here at Concordia University in Montreal, and Fabio is a professor at ETS as well. So what is the ASE4Games workshop? The idea of the workshop is bring the communities together, the software engineers, and the game engineers. Encourage discussion so that we can create a stronger community. So in this workshop, we identify and explore the new research challenges, cost and benefits of entertainment games, but also serious games, gamification, and traditional applications and non-game applications as well. The idea is to generate new research agenda, identify topics of interest for the community, and explore further the new topics in the future workshops. So this workshop is structured to be highly interactive, encourage discussion, and appeal to the participants from either academia and industry. So thank you very much for all the committee members that help us either reviewing the papers and giving feedback. Without your work, this workshop would not be possible. So should I name? I think I should name. So Mathieu Nehol from Ubisoft. Okay, sorry for the mistakes in the names and especially in the last names, but I will try my best. Apostolos Apanzoglou from the University of Macedonia. Cyprian Paduraru from the University of Bucharest, also from the University of Bucharest, Alin Stefanescu, Vishnu Prasetya from Utrecht University, Antonio Sicchetti from the University of Mallardaling, also Chris Alexander Chatchis-Georgiou from the University of Macedonia, Felipe Lima from the National University Institute for Space Research, Paulo Meirelles from Federal University of ABC, and Clark Verbruch from McGill University. We had 5 full papers received, and luckily all the 5 papers were accepted and will be presented today in the workshop. So the program of the workshop is this. We have this short welcoming and opening. We have 3 paper presentations with the Q&A, question and answer, around 25 minutes each. After that, we have a break, like a virtual coffee, like 10 minutes. We can discuss and talk among ourselves. After that, 2 more paper presentation with the QA, another quick break, and then we have our keynote, lasting around 1 hour together with discussion, I believe. And then we have a closing, final remarks of the workshop. Before we start, this was a good idea from Professor Jan. he invited us to create or to do a virtual beach ball that we can present each one, and therefore we can meet everyone here. I can start with myself, I guess. Is that am I breaking the rules already? I don't know. So I'm Cristiano Politovski. I'm a postdoc here at living in Montreal, Canada at ETS. I'm Brazilian. Well, I love video games. I love software. Therefore, we are here to discuss about both of those topics in this workshop. So maybe the next one, Fabio, could you present yourself?
Sure. So thank you, Cristiano, for the opening and also to help in the organization, all participants. My name is Fabio Petrillo. I'm also the organizer and can say one of the proposals at this workshop. So I'm associate professor at École Technologie Supérieure at Montreal too. And I have more than, can say, near to 20 years working on thinking about this phenomenon is video games and software engineering. I love this topic, and I think you have a lot of work to do. So it's super my pleasure to be here with you today. So maybe the next one could be Paolo.
Yes. Yeah. Hello, everyone. Yes, I'm Paolo. I'm associate professor at the National Institute of Informatics in Tokyo, in Japan. Actually, I'm rather new in this community. I mainly work on software testing and search-based testing mainly. But yeah, thanks to our industrial collaboration here at our institute, we started investigating kind of testing of games, and yeah, I'm looking forward mainly to learn from you, and yeah, I'm looking forward to work more on this topic in the future. So thank you. Nice to meet you.
Maybe Jan?
But the idea that's Paolo to choose someone to.
Oh, okay.
Sorry. Okay, I didn't get. So the next one in the list is Carl.
Thank you. So, hello everyone. I'm Carl Terrien. I'm an associate professor at the Department of Art History and Cinema Studies at the University of Montreal. I'm a game scholar and film scholar. And I've been working on video game history for the past 12 years. My thesis was on immersion in video games. So it's a real honor to be with you today. The fun of my job is getting to collaborate with so many different academic communities. And so I'm really, really happy for this invitation. And so I guess I can pass it to Jan, who was just about to speak. Thank you.
Can you hear me? Oh, maybe if Cristiano, you have to switch off your speakers too.
Yes, it's off. Yeah.
So yeah, good morning, good afternoon, good night, everyone. So my name is Jan Gael Genek. I'm professor at the University of Concordia. I'm Canada researcher in empirical software engineering for the IoT. And I came to games because it's a fascinating topic. I've been a player for a long time. Cristiano can testify that I've been asking him to put Rick Dangerous in his PhD thesis about game testing for a long time, but he never did. But games are fascinating, and the software engineering aspects of games especially interest me. How games are developed, how games have been evolving as well. From like very simple games that we had like 50 years ago to those big, massive 3D engines that we have nowadays. So that's really my interest there, including architecture, testing, development methodologies, and so on and so forth. And I love also the history of games, so that's how I got in touch with Carl, who has a lot of interesting things to say about that. So thank you very much. And I'm passing the virtual beach ball to randomly on my screen, Rihanna, if you could introduce yourself.
Yes, I am Raihana Firdaus. I am a postdoc researcher at FBK.
We cannot hear you, Rihanna. Can you hear?
Yeah. Can you hear me?
Oh, yeah.
Yes, we can.
Okay, sorry. So I am Raihana Firdaus, and I am from FBK, Fondazione Bruno Kressler. I'm working as a postdoc researcher here. It is in Italy, sorry to say. And good afternoon, everyone. Here it's in the afternoon. And as I was saying that I'm a postdoc researcher here in FBK. It's a research center, particularly doing research in a varieties of range from religion to informatics and to networking, all the things. And I'm particularly working in software engineering group here. So we do software requirement analysis and testing, but I'm quite new in this field. Particularly I am interested in using reinforcement learning in software testing. And this I'm here to learn more from you as I'm very new and hope very interesting, hope to get some very interesting discussion today. That's all, thank you. So I'm passing this beach ball to Cyprian. We cannot hear you.
Can you hear me now?
Yes.
Yeah, okay. Sorry. So I'm an associate professor at the University of Bucharest. I am here with my research team with Alin and Radesh, also in this meeting. I am also passionate like you about games development. I worked a lot in the industry and I still collaborating with them on the research topics. Also, I've been passionate on testing games using methods like reinforcement learning. So I saw that there are a few persons here that are also passionate about testing and the reinforcement learning field. So maybe we can create more projects together. Who knows? I am gonna present you how to transfer learning from cars behaviors from reality to simulation applications like games, for example. Yeah, I will pass the ball quickly to the next person.
You can choose someone.
Who's next in the list? I don't know. Who didn't present it?
Alin.
Yeah, Alin. Yeah.
Hi, everybody. I'm a professor at the University of Bucharest. I'm a colleague with Cyprian, and actually he introduced me to the fascinating world of games. Because he has a lot of experience in industry, so when he fully moved to academia, we thought to use his experience and our previous experience in software testing, software engineering, to tackle some nice problems in game engineering. And also my small son, who is 12 years old and also a gamer, he was also very happy to hear that I'm doing research, not only like boring stuff, but also real stuff like games. Okay, thank you. I pass the ball to Kazuki.
Hi, thank you. I'm Kazuki Wayama. I'm a student at graduate school at Okayama Prefecture University. Nice to meet you today. Thank you.
Please, Kazuki, choose someone to continue.
Tomoyuki Yokogawa, Mr. Tomoyuki Yokogawa.
Oh, thank you. So, I am Tomoyuki Yokogawa, associate professor at Okayama Prefecture University in Okayama, Japan. So, my research interest is formal verification of software, especially video game script. So, good evening. So it is 22 o'clock in Japan. So my family is already sleeping. Thank you. So who is next?
I think it's done.
So, yeah.
I think you complete the presentation, Christian.
Okay, thank you.
Yeah, thank you very much for everyone. And I saw a lot of testing fellows that me as my thesis was about testing too, and also reinforcement learning. See the small world. So continue here in the workshop. Thank you very much for everyone attending. We're going to start right away with the first paper. So I'm going to call, I believe Kazuki is going to present or Tomiyuki, not sure. The title of the paper is Verifying Game Logic in Unreal, Game Engine 5, Blueprint Visual Scripting, System, sorry, I'm going to restart. Verifying Game Logic in Unreal 5 Blueprint Visual Scripting System using model checking. So whenever you're ready, either Kazuki or Tomoyuki, you can the floor is yours.
Okay,
Stop the share screen, Christian. Okay.
just a moment, please. Could you see screen? Okay.
Perfectly.
Hello, everyone. My name is Kazuki Wayama. I'm a student at the Graduate School of Okayama Prefecture University. Thank you for introduction. Today, I would like to talk about a method to verify game scripts created with UE5 blueprint using the NUSMV model checker. I would like to begin with background of our research. In recent years, game development using UE5 has been widely used in the game industry. In UE5, variables and functions are treated as visual blocks called nodes, which can be combined to represent game logic. This makes it possible for users without programming expertise to intuitively describe game logic. However, the larger the game, the more complex a number of blueprints will be. As the size of the game scripts increases, blueprints grow in complexity and size, making it difficult to find and fix even simple bugs. So in this study, we use model checking to automatically detect bugs in game logic. Next, I'd like to explain about model checking. Model checking is a formal verification technique that uses the state transition diagram and its verification characteristics as input. It performs an exhaustive verification of the system to determine if the system satisfies the validation properties. And if the verification property is not satisfied, the state sequence up to the state where the property is not satisfied is output as a counterexample. In addition, the verification characteristics are based on temporal logic. NUSMV is one of the implementations of symbolic model checking. The models to be verified by NUSMV are written in a specific input language called the assembly language. The structure of the assembly language consists of three parts: the variable declarations described by var, the transition definitions described by assign, LTL and CTL expressions, which are the properties to be examined, are annotated into the input model using LTL spec or CTL spec. Next, I'd like to talk about UE5 Blueprint, a visual scripting system. Here is one example of a blueprint. It visually describes game logic, such as player and enemy character actions, score calculations, by connecting nodes. This makes it possible for users without programming expertise to intuitively describe game logic. However, the number of blueprints and the type and number of nodes included will vary depending on the size and complexity of the game. Let me explain previous example in more detail. A blueprint consists of nodes and wires. A wire connects either only between the execution pins or between the data pins. Only connections between pins of the same data types are allowed for the data pins. The flow of execution represented by the wires connecting the execution pins is called the execution flow. Similarly, the flow of data represented by the wires connecting data pins is called the data flow. The nodes involved in this example are event nodes, function nodes, flow control nodes, and variable nodes. An event node is a node that serves as the starting point for the execution of a blueprint. A function node is a node that implements a function for a value in a program or a node graph that can be invoked from other graphs. A variable node is a node representing a variable for holding the value of an object or actor. This blueprint involves three variables. Speed is an integer variable and stores the player's speed in 11 steps from 0 to 10. Its sprint is a Boolean variable and indicates whether or not the player is in a sprint mode. Its max speed is a Boolean variable and is activated when the player's speed has reached its maximum value. This blueprint illustrates one execution flow. First, the variable sprint is set to true, and then the variable speed is incremented. If its max speed is evaluated to be true, then the SE is played and speed is set to 0 and its sprint is set to false. Actually, a typical bug lurks in this blueprint. If its max speed is evaluated to be false, when the execution flow reaches the branch node, the execution flow of this blueprint terminates at that point. Thus, the flow never reaches the following set nodes, and its sprint flag will remain set. Flags that should be unset remain set may prevent the game from progressing or cause unexpected behavior. This is a common error in flag management, but one that is very easy to overlook. As similar in previous study, we define the semantics of a node as functions over the elements involving the node. The node can have input and output execution data pins. The value of the output data pin changes according to the value of the input data pins. A set variable node assigns the value of the input data pin to the associated variable. Thus, the value of the element EL and the triggered execution pin EX in the next state is defined as follows, where EX denotes the triggered execution pin and EL prime denotes the value of EL in the next state. E is composed of the input and output data pins and the variables. We will describe the node semantics for each type of node in detail. Variable nodes are classified as get variable nodes and set variable nodes. A get variable node has a single output data pin, and the value of its single output data pin is always the same as the value of the referred variable at that state. Therefore, its node semantics is given by this formula, where the out denotes the value of the output data pin and var denotes the value of the variable. A set variable node has a single input data pin and input and output execution pins. When the input execution pin is triggered, the value of the input data pin is assigned to the variable associated with the node, and the output execution pin is triggered. Thus, its node semantics is given by these formulas, where D in denotes the value of the input data pin and E in and E out denotes the input and output execution pins. A function node can be either a pure function node without execution pins or a non-pure function node with execution pins. A pure function node has input and output data pins and has no execution pin. The value of the output data pin is determined by the value of the input data pins. The transition relation of the output pin, d out I, is given by this formula, where the function fi is defined according to the node. A non-pure function node has input and output data pins and has input and output execution pins. Similar to a pure function node, the value of the output data pin of a non-pure function node is determined by the value of the input data pins. However, in contrast to a pure function node, the non-pure function node performs the computation when the input execution pin is triggered. Thus, the transition relation of the output pin DOUTI is modified in this way. The non-semantics can be obtained as a set of formulas representing transition relations for all output pins. The flow control node triggers one of the output execution pins depending on the values of the input data pins and the triggered input execution pins. Thus, the transition relation of EX involving the flow control node with output execution pins is generally expressed like this, where this part denotes the condition for EOUTI to be triggered. The branch node shown in the example controls the execution flow provided that the flag is true. In this study, we achieve verification by NUSMV by converting game logic written as blueprints into SMV programs. First, let's look at the data flows. To model data flow, it is necessary to represent what data has transitioned from which node via which pins and wires. For this purpose, SMV program variables are assigned to each data pin at each node. Here, the type of SMV variable to be assigned is determined by the type of the corresponding data pin. For example, if the data pin is of the Boolean type, the corresponding SMV variable should also be of the Boolean type. Note that two pins connected via a wire have the same value with respect to data flow, so it is sufficient to assign one variable. And now let's talk about execution flows. To model execution flow, it is necessary to represent which execution pin is triggered in the next state. Only one of the pairs of execution pins connected by a wire is triggered at the same time. Therefore, to represent the execution flow, it is sufficient to define one SMV variable that has as its domain the execution pin pairs. Next, I'd like to describe the procedure for modeling the example blueprints. First, setting SMV variable. First, modeling the data and execution flows. Second, modeling the behavior of nodes. Then, integrating the model fragments. And then, annotating the specification. And finally, verification the model by NUSMV. The output data pin of the get variable node's speed and the upper input data pin of the function node at are of integer type and take values from 0 to 10. So the wire between them is defined as an integer variable, W speed at, in the domain 0 to 10. Similarly, the wire between the output data pin of at and the input data pin of the second set variable node is defined as an integer variable, W at set 2. The output data pin of the get variable node is max speed, and the input data pin of the branch node are of Boolean type. So the wire between them is defined as a Boolean variable, W is max speed branch. Note that there can be a state in which the value of a variable is not defined, such as at the beginning of a blueprint execution. When we introduce a new flag variable to indicate that the variable is undefined, D speed at D add set 2 and D is max speed branch are Boolean variables indicating these variables respectively. The variable speed is sprint and is max speed are defined as V speed, V is sprint, V is max speed respectively. As for the execution flow, the flow can be expressed by defining a single SMV variable. The value and if indicates that no execution pin is triggered. Second, I'd like to talk about modeling the behavior of nodes with respect to data flow. We can model the behavior of nodes by representing the transition relation of the values of the output data and the execution pins and the variables. Here is the example about the flow from the add node to the second set node. The initial value of the data pin is assigned non-deterministically. Unlike a get variable node, the value of the output pin of a function node also depends on whether its value or involving input pin's values are already assigned. Specifically, if its value has already been assigned or if the values of input pins have not yet been assigned, its value is not changed. Additionally, the flag variable d_set2 is set to true when the values of input pins have been assigned. The transition relation of the output execution pin can be represented by integrating the transition relations of nodes involving the execution flow. The transition relation of the triggered execution pin EX can be represented as a change in the value of the assembly variable EX as in this example. The triggered execution pin in the initial states is that of the event node. For nodes with input data pins, EX is updated after the values of the pins are determined. The variables are classified into internal and external variables, where internal variables are those whose values are assigned by set variable nodes, and external variables are those whose values are determined by external components such as other blueprints or input devices. In this example, speed and isSprint are internal variables, and isMax speed is an external variable. The initial value of the variable is assigned non-deterministically. And since set2 and set3 assign the value to the variable speed, and the transition relation is obtained from the node semantics of those nodes. If the input data pin of a set variable node is connected to another data pin via a wire, the variable is assigned a value only if the value of that data pin has already been determined. Similarly, the transition relation of the variable isSprint is obtained from the node semantics of set1 and set4. In addition, because the behavior of external variables is determined outside the blueprint, their values change non-deterministically. By integrating the fragments of the assembly program shown so far, a model for verification can be obtained. To perform verification by NUSMV, it is necessary to express the properties to be verified in temporal logic. The error in flag management, as shown in slide 7, can be detected by this CTL formula. This CTL formula expresses the property that isSprint will eventually be unset if isSprint is set. What we found that NUSMV can detect bugs and support the bug analysis with the generated counterexample. In this slide, I discussed the approaches for reducing the state space of the modeled blueprint. Since large-scale game logic consists of many blueprints, the number of states in the model can explode, making verification in a practical time difficult. Factors affecting the number of states include the number of nodes and the number of pins in each node, which affect the number of assembly variables, as well as the range of the domain of assembly variables. We discussed the approaches for reducing the state space of the modeled blueprint. In addition, in game programs, many nodes perform complex calculations. There is a significant possibility of a state explosion due to the large definition range of each variable, and the flag variable indicating whether the value of each variable is already assigned is also required. So we seek to reduce the number of states by abstracting the domain of variables in modeling, thereby reducing the cost of verification. The modeling method mentioned above takes one-step transition to propagate data from the input pins to the output pins of a node. Consider 3 pure function nodes connected as shown in this figure. Since the 3 function nodes are connected in series, the following 3 steps of transitions are required for the set node to obtain the result. By integrating these processes, the result can be obtained in a single-step transition in this way. If the property to be verified is highly dependent on the execution flow rather than the data, it is possible to verify the desired property without rigorously modeling the contents of the data flow. As an example, we consider modeling a node that calculates the area of triangle. 2 to the 60 power variables are required even if the target area is limited to a rectangle with 0, 0, and 100, 100 as diagonals. By changing the target area to a rectangle with 0, 0, and 10, 10 as diagonals and abstracting the domains of those assembly variables, the number of states can be reduced to about 2 to the 35th power. Furthermore, if the contents of the data are not strictly modeled, but only the flow of the data is represented, the number of states can be significantly reduced by eliminating all but the flag variables and the property affecting variables. In this slide, we provide a preliminary evaluation of the effectiveness of the state reduction approaches mentioned above. The original model obtained by the proposed modeling method and the models obtained using optimization and abstraction are shown in figure below. The verification was completed within a short time in all cases, and the target bug can be detected in the model with optimization and abstraction as well. In addition, the number of states and reachable states of the model can be significantly reduced through optimization and abstraction. Thus, the processed state reduction method is expected to decrease the cost of verification even for large-scale blueprints. Finally, here is a summary. In this study, we proposed a method to verify game scripts created with UE5 blueprint using the NUSMV model checker. We performed modeling based on the proposed method on an example game script and confirmed that typical flag management bugs are correctly detected. And we found that the proposed optimization and abstraction can significantly reduce the number of states and the cost of verification. Future work should include a quantitative analysis of the effects of model size reduction through optimization and abstraction on practical examples, as well as the frequency of bugs missed due to abstraction. Besides, it is necessary to evaluate the verification cost and bug detection rate for practical game scripts in order to improve the usability of the proposed framework. We will also develop an automated modeling and visualization of counterexamples. Thank you for your attention.
Thank you so much, Kazuki, and also Tomoyuki for the paper, and very interesting. I'm glad that you already working on Unreal Engine 5, and we all know that the blueprints could be a nightmare if the scope of the game or the script is too big. So definitely this is very worth worth research field. Do we have any question?
Yes, time for questions. You have a lot of aspects I think discuss around. Cyprian, don't be shy.
You can just speak up.
I cannot hear you, Cyprian.
Can you hear me now?
Now it's perfect.
Yeah, okay. Thank you. So I really like the idea that Kazuki presented. I think it's very valuable today to test the blueprints. in whatever methods we have in hand, but especially with this kind of model checking. But I am a little bit worried about the state space, to be honest, especially on like full environments like 3D games and so on. I mean, it's almost impossible. But what I think it could work in general to continue this nice work is to focus most on niche things, on things that on small systems that have a limited search space, that to give the user the chance to set his space, to abstract his space, because the user knows better what parts of of the state of a blueprint needs to be tested and which is not important. Yeah, I mean, if you let a full blueprint variable with all the variables to pass through a SMT solver, it or model check, whatever method you use here, it's not going to work in the industry because it will be too slow from my perspective. But if you let the user like select a bunch of states and you focus on niche things like small systems and so on, it could, from my perspective, become very valuable. Okay, thank you.
Thank you.
What do you think, Kazuki? Have some comments? Because some people sometimes could attack your work in good way, say, as Cyprian said, it's a little bit hard maybe do this formal checking approach. How you could convince game developers to use your approach? Because sometimes it's, as Cyprian said, is a huge space for analysis, for model checking. That how we more operationally you think to convince, you could convince game developers to use your approach?
I can answer. Not that you need my answer, but
Tomoyuki tried to speak. Hear him.
You are listening, Chris.
I think Tomoyuki is trying to speak.
Yes. Yes. So as I pointed out, so I also think it is difficult to search the state space of the for script. So we focused on the for example, so flag management of control flows, or so to carry out the verification. So we have so abstraction of state space. So but even if we abstraction is carried out, so we can detect some bugs of script. So in our previous work, so we can detect some bugs of scripts of video game, so Final Fantasy, even if it is very, very typical bug, so of flag management. So we can detect some bugs of script using model checking. So, but as you pointed out, so it is not stated also 3D games or some very, very big domain or variables. So it is we don't focus on such a problem in our method. Thank you.
Thank you very much for the answer and the question. Unfortunately, we have to move on because but we can just continue discussing in the Discord. We can continue over there, but I'm gonna share and moving on. We have a schedule to follow, right? And I just pressed. Let's see. Okay, 1 second. The next presentation is, I believe, Ezequiel going to present, Ezequiel Castellano.
No, I'm Paulo.
Cristiano is Paulo.
Oh,
Sorry,
sorry.
Ezequiel will be here.
Sorry, sorry, Paulo. Paulo Arcaini. The title of the presentation is "Explaining the Behavior of Game Agents Using Differential Comparison." So the floor is yours, Paulo.
Yeah, thank you very much. So hello everyone. Exactly, I'm Paulo, and actually I'm reporting the work mainly of Ezequiel Castellano, who cannot be here, Xiaoyi Zhang, my colleagues, Toru Takisaka, and Fuyuki Ishikawa. So these are all my colleagues that were working at NII. Some of them Toru moved recently, and two of our industrial partners. So exactly, we just started working on this topic, and the goal of our work was to try to explain the behavior in game agents that are used during testing. So the outline of the talk, I will briefly introduce the type of games or the context, type of game that we are considering, and which are the concerns that we have. So what we want to guarantee, particularly this game balance, and try to outline what is testing, which is not state of the art, but what you can do for testing these type of systems, these type of games, and how actually this has been is been doing in the company, but still, which are the issues there that these game agents that are using are not too understandable, and so the approach we are proposing to try to explain these game agents. So let me, as a disclaimer, I cannot really provide also in the paper too many details on the type of game, or either the name but still, okay, we'll try to give the intuition. But you may think it's a game on a mobile phone. I don't know, this is the best icon I found, but I will exemplify with this icon. And multiple users, of course, they can use it, and basically they need to interact with a virtual character from which they can improve it over time. And the game is provided as game as a service, meaning that users can buy from time to time new features, like, I don't know, a new weapon or a new strength, or identify new task to do in the continuation of the game. And so each update of the game can introduce this new feature that can be bought by user. Sometimes, okay, the update is also due to a bug fix, or sometimes to a game tuning. So developers of the company identify that the game must be tuned to balance better, what we call later this game balance. Here there are totally random dates, but what I would like to exemplify here that the frequency of these releases is quite short. So the frequency is quite high, so the releases are quite close to each other, meaning that there is not too much time for testing. So for example, a few weeks between the two. So what is a very important aspect for this type of games is what we call, and in the literature is called, game balance. So the game balance depends on two aspects. So from one side, we want players to keep on playing. so that they are they like the game, and not only they like it, but they keep on playing. So they're encouraged to continue playing. And on the other hand, we want the company to make money. We want the revenue of the game should increase over time. And which are the features that the players why they want to keep on playing? So in that to do this, the game should not be neither too difficult. I mean, extremely difficult that nobody can actually improve, or neither too easy because it's not too interesting. As I showed before, users can pay, and if they pay, they can obtain some, for example, items. But there should be not too much advantage for paying users. Otherwise, those who are not don't pay, yeah, they are discouraged and they will give up the game. So sometimes we can see that the game balance depends from the user point of view in a balance between play to win, so in which players, a user who actually play to achieve item, and those that from time to time pay. So there should be a right balance between these two aspects. Of course, this is a very there is a lot of research, but how to assess that there is a right game balance. So as I said before, this game is updated quite frequently. So whenever the company produces a new update, they want to think or they want to assess whether the new release will provide a good game balance. And yeah, they can do by test. So the idea that they can run a lot of execution, a lot of interaction with the game by simulating different type of players with different playing strategy, and they can also try different configuration. So for example, different rewards given to players, and try to see which of their configuration allows a better game balance. But the issue is that for doing this testing, you cannot really rely, in particular in this setting, only on human testing, because not only it's costly, but also the time is too limited to conduct a large test assessment of this game. So what the company started investigating is to use what I call here game agent, so artificial agent, so software that automatically plays the game. So they are experimenting with different type of agent, rule-based or reinforcement learning agent. And of course, the advantage that they can, these agents, they can play for a long time, and they can try a lot of different type of execution, different type of configuration in an automated way. So these somehow for the company solve the automation problem, but still their issue is that the playing strategy of these agents was rather, in some cases, rather obscure to them. So in particular, those on based on first learning, they were wondering, they need to understand what is the agent, which is the playing strategy of the agent. For example, because, for example, let's suppose that an agent had a very high performance. They want to understand, okay, did the agent discover a very good playing strategy, or it's just the game that is not tuned correctly? So one of the issues for them was try to explain what game agents do. So explain their behavior. And this was our initial task. So try to explain the behavior of using in-game by game agents in testing a gas. So starting with existing explanation technique that, for example, provide decision trees, was not really providing any interesting findings to us. So what we were finding were rather apparent results. So our initial idea was to try, we take the analogy from differential testing. So differential testing is a testing technique in which when you have a system, when you have two implementation of the system and you provide the same input to both implementation, and you check if there is a difference. So differential testing use in particular to solve the Oracle problem. Here, we don't really use for that, but the idea that we use a kind of differential testing setting to explain game agents, because by comparing what two game agents do given the same input, somehow we capture the unique behavior. So in all the cases that are trivial in which they behave the same will be discarded, but what we can do, we can narrow down the unique behavior of one agent. And how we do it? This is the overall approach. Basically, we have 4 phases. We have a phase of test generation. I will go through, and then we need to align the test. So we need to execute both agents from the same, let's say, state. I will explain that. The outcome of these phases is a set of comparison data from which we can do some analysis. So we can try to get some explanation. So in this setting, I will consider that we have 2 agents that we are comparing. So I will call them AJX and AJY. Okay, I'm not giving any definition, but okay, what an agent, so when an agent interacts with the game, we can see it produces a sequence of states. So the states, these are the states of the game and of the agent. This can be, I don't know, the power or the status of the other characters and so on. So you can think, and in a given state, each agent performs some action. Of course, there is a set of available action, and the agent pick one of these. So we assume in this context that the agents are deterministic because these are the case in our for our case study. So basically, what the action that is taken by the agent somehow identify its strategy. So just as a terminology, for us, a test is just a single state. So we will consider each state as a test. So it's the input in which you initialize your game. And the test pair, we call it the pair with the state with the action applied by the agent. So which action was applied by an agent in a given state. So what we do in test generation, at the current stage, for the 2 agents, we just do random testing. We produce random, in particular, we initialize in a random way the game, and then we keep on playing. And so with a given length, I don't remember, I think it's 50. And then what we do, we split this test in test pairs, because this is what we care. So TPX for us is a set of states with a given action for the agent. And we do this for both agents. What we need now is that we need to compare the agents on the exact same state. So what we do, we take for the other agent, we take the test pair of the other agent. So for example, for Y, I take the test pair of X, and I execute Y from the state in which X was executed. So long story short, we execute both agents from the same state. So at the end, these 2 sets, they contain the exact same state but with the action that they were chosen by the 2 agents. So we can see how they behave either the same or differently during in those states. And yeah, what we also, as a supporting data structure, we build something like this for each pair of actions. So these are 2 possible actions of the game. We collect the states in which the first agent play AI and the second agent play AG. And we do this for all the combination, even for the exact same action. So we also check the states in which they play the both action AI. So this is somehow the data that we use for building our analysis. and how we use this data. So the first analysis we do is rather simple. So here we call this frequency metric. So each of these cells, so here you have the two agents, so these are the action. Here you have the number of states. So basically here we are counting how many states are here. So are the number of states in which one agent play, for example, let's say here, agent agent Y play 7 and agent X play 3, A3. So we do this for all the combination, and what we can, by just looking at these type of result, we can get some conclusion, or can get some explanation. For example, we identify actions that are in which we call it complete agreement. This is this green column and row. And yeah, this makes sense that there was a complete agreement, because in somehow in the game, this for us is used for progressing the game. And so there was no reason not to select this action. So this was a kind of sanity check that our technique makes sense. But in other case, we find a strong disagreement. For example, when agent Y plays A4, we see that agent X plays quite different actions. There are still some actions that are played, but there are also quite a lot of states in which they play different actions. And if we look at these two A4, actually A4 is a rather, I would say, conservative action. So in the game, it avoids to lose energy, but it's an action that is used to somehow refill or to improve, to refill your character, to increase the energy. So somehow this describe, and also other observations that we have in the paper, that this agent is rather more, let's say, a little bit more conservative in this policy than agent X. And then we have other actions that are somehow in between, like A3, in which, although there is some disagreement, like in this case, but we see that A3 still have quite a lot of common states. Here I call it mild disagreement. Maybe it's more, could be also a mild agreement. But yeah, that is the type of analysis. So here at the beginning, we just have this quantitative analysis in which we have an understanding of roughly which action they agree and they disagree, but we don't have an explanation of why. So, okay, now we have the states, but why they agree and why they disagree. So what we do, we given a pair of action, for example, AI and AJ, we take from all the states that are in this AI AJ, basically we take the values of the variable. So we collect for each, for a variable X, I take the value of X in that in those states. And I do for a pair of action, or for a pair of action, for example, AI and any other action that is not AI. And how we do this? So how we use this data? We use this data to do what we call disagreement check or agreement check. In disagreement check, basically we compare all the values of AI and AJ. So AI and AJ are two different actions. So I compare the value of X when one agent plays AI and the other plays AJ, with the same value of X when they play the same. So which is the idea here. So basically I want to see what is the difference in the states, in this case, in this particular variable X, when they play the same or when they play different. So how is the value of X different? So I check if there is a statistical significance. So we do this with Mann-Whitney, and what is important here is the effect size. So if there is a significant difference, we check the effect size that tell us the strength, and here the color basically red means lower, significantly lower, and blue significantly higher. And so what we do, we print, we build these type of tables in which we can analyze the data. So how to read these table, these measure. So for example, here we have when agent Y play action free, action A free. So how are the values of how are the values of the variables of the state when agent X play A6? And here we see that for most of the variable there is a significant difference. So here we say there is a multiple variable cause. So if we see that from the case in which they agree, by changing quite a lot of variables, of course, we introduce different issues, different reasons for disagreeing. So the more the states are different, the more it's likely they disagree. And again, if we look at these type of variables, we see that these are related to somehow the strength of the character. And that still explain why they play different actions. So display why agent Y decided to do one more conservative action while agent X do another. But in some cases, yeah, the explanation is much narrow. So there is, in this case, there are just these two variables in which they differ. And these two variables are somehow related to the time during the game in which it is played. So they are also kind of related. And this means that it's a kind of important factor. So the less variable are in the explanation, it means that the more that the variable is important for that agent, because just it's enough that that variable is different for taking a different decision. So this, yeah, exactly, was a, and of course we do this for all the pair of actions. So to conclude, so our initial, the starting point of our work that game agents in our partner and industrial partner, they use game agent to test gas, but they would like to understand exactly which is the logic behind the game agents, because yeah, based on that, they can better configure their game. This only is the beginning. So now we are just at the stage in which we are explaining the behavior, but in the future we should also would like to correlate the behavior with the performance, really to see, okay, if there is one agent that some playing strategy is better than another in terms of performance. And now, yeah, we do the analysis for two agents, and but yeah, we would like to extend also to multiple agents. And yeah, it's not here, but also related to previous comment. So we also need some abstraction techniques to try to scale a little bit, because now the variables are not too many, but yeah, if we have a lot of variables to characterize the states, we will need some abstraction techniques or just identify few variables. And yeah, that's conclude my talk. I'm happy to answer any question. Thank you.
Thank you so much, Paolo. Very, very interesting talk, very interesting problem. It's very similar to my thesis, to be honest. But we have time for maybe one, maybe two quick questions. I see that Carl just clapping. Anyone with questions?
Maybe just one quick question, Christian, because Paulo, super cool work is, as Christian said, is you are in the same direction. But why you discuss game as a service? Because maybe this approach is more general, or there is something specific for game as a service?
I think
Yeah,
this is a trend in the industry, right, Paolo, to have games that are continuously updated through small features.
yeah, exactly. I mean, exactly. As I said, I'm yet to learn. I mean, this was somehow our setting, so that was yeah what we were given. But yeah, I think that I think yeah, it's more general. I mean, it can explain also other type of game, not necessarily
Mm-hmm.
somehow. Uh, so for us, game as a service was since you have these frequent releases, you need to
Mm-hmm.
use game agent. Okay, I'm not an expert, but I think if you have, I don't know, releases of 1 year, you can use also human players. But yeah, that's, I don't know. This is my intuition that, yeah, if you have such a short release time, you can only rely on artificial agent test your, or mostly you need to rely on this type of. But
I
yeah,
would just, yeah.
yeah.
Paul,
Please.
I just have a suggestion. In general, from my experience, the game industry isn't really using like reinforcement learning for most of the agents. It's like more a kind of scripted agents that runs on the top of behavior trees, on decision trees, and so on. So I was just thinking in the past if those models basically are more explainable, right? So if you have the same work that you describe now, and you want to compare what was their behavior in the states, what makes them different, maybe it's easier to explain on those kind of scripted stuff, on the rule-based, the behavior trees and so on, rather than on reinforcement learning agents and black box network type of things.
Yeah, I totally agree, because in case of rule base, I could check, I don't know, coverage, activated
Exactly.
rules. Yeah, that's
Even the flow, if it's the flow of operations
yeah.
that they check at runtime. So
I cannot. Yeah, my answer, I don't. I mean, because I know that they are investigating this type of agent. They also have a rule base that, but that exactly was easier because one of I cannot really tell, okay, which one in the end is better. So that I don't know, in the sense if there is, in terms of even, because maybe reinforcement learning agent in the long term are able to, I don't know, find better strategy or more.
yeah, they are better to find exploits.
Yeah. So in the sense that, yeah, exactly, because in the end, maybe a rule based, you put your, somehow you need to put your domain knowledge instead. Yeah, with the reinforcement learning agent, we try to learn some good strategy, but then then you have the problem that you don't know what they learn, and so that's because. But I agree that with more simple, I mean, with rule based, no structured agents, the explanation will be easy.
Okay, guys. I'm sorry. I would like to discuss more and let everyone discuss more this subject, but we have to go. We're a little bit late. We're 13, 14 minutes late. The next paper is Professor Cyprian. The title of the paper is Transfer Learning of Cars Behavior from Reality to Simulation Application. The floor is yours, Cyprian.
Okay, thank you. Tell me when you are seeing the window, the screen with my presentation.
It's perfect.
I'm seeing.
You are just, but not presenting mode yet.
Yes.
Sorry, do you see the slides?
But not in presentation mode.
Let me try again. Do you see it now? Not in presentation mode. Okay, maybe if I. Okay.
Yeah.
Yeah.
Yes.
Can
Now
you see
it's
it now?
perfect. Perfect.
Okay. Okay. Thank you. Okay, so I'm the presenter. You have the Git here. It's open source for presentation, but I will make quickly, since we are behind schedule. So the introduction, why would we need to transfer learn the deep learning models of vehicles behaviors to simulation agents? So first, we can observe that the self-driving cars field has made important progresses in the last while using the deep learning methods. Then the methods mostly address the safety of the traffic regarding to the agents like participants like cars, humans, cyclists, and so on. Our main premise is that if we have a car agent that is trained on real world data, then it could behave more credible than using the hard coded and classic game rules. So the idea was, let's try to transfer learn those models from the self-driving cars field to simulation engines and games. Our main contribution to the state of work is to study how to study the current state of the art self-driving cars model first, and check which one can be adapted to the game development and simulation development industry, because there are two things that needs to be first. The goals, of course, would be to have like vehicle motions that are more believable to the end users, and the second would be that to reduce the cost that the companies are making with the development of such behaviors, because it's always like it's not trivial to hard code and to produce such scripted agents that behave realistically. From our knowledge, this is the first open source work that would integrate real world agents that are trained on real world states. You'll see or data source that were used for training. We have made it open source. All the experimentation at this link. I will put it. It's in the paper. Okay. Then we integrated this all this evaluation and experiments using an open source game engine like it's well known, the Unreal Engine, and Carla Simulator. Carla Simulator is, just for your knowledge, a self-driving car simulator that it's on top of Unreal and has some nice functionality for the self-driving cars field. Okay, so let's review a bit the related work, and first let's see the data sets and metrics that we used, because these are quite important to understand the field. First, we have used the Waymo open dataset, which is the currently I would think the state of the art from what I experimented with. It's like the hugest one for that offers real data from US streets. It has samples of 9 seconds each, captured at 10 hertz. It contains trajectories of vehicles, pedestrians, bicycles, and so on. It provides both images from the traffic and trajectories, 3D trajectories, captured from LiDAR data. And for a set, let's say, denoted by G of vehicles, it gives us the true location of each time step of those 9 by 10 hertz. So for each agent A, to have like a abstract problem formulation, for each agent A, the goal is to find a function that would take the input X, which contains the historical states over a time period T of the surrounding agents, and S is the environmental context. You will see what the environmental context is formed of, and it outputs a set I hat, which contains k possible trajectories for the agent A in discussion. Now, why all these state-of-the-art models in self-driving cars are using k-possible trajectories? Well, you know that trajectories in the real world of both humans, cars, animals are multimodal, right? So you can take different decisions depending on the environment and some unknown factor that are not observable. Now, about coming back to the environmental context, as this is encoded using usually from a bird's eye view, but not only. I will explain a bit. That is processed semantically. Well, there are one of in this picture there are four semantically processed bird's eye view used in the RECO-AT model, one of the model that we reviewed in deep, where you can see that the red rectangle here is the target agent that we need to predict its trajectory over the next frames. The purple ones, the purple rectangles, would represent the agents that are surrounding that agent. The tails explains their past, the history positions in those t times history points, and the red and green dots on the street are representing the traffic lights, where the traffic light is either green or red. Now, about this, it is not limited to bird's eye view, because you can always reconstruct a scene. If you have multiple images, there is a whole discussion in the computer vision industry. You can basically compute some reconstruct an image like this. If you put a camera on top of your car with lidar and everything, and cameras, of course. And the metrics that are used usually for evaluating this kind of models, we have like a set of 5 metrics, but only the first two are, let's say, very important to the simulation engines and game industry. So first is the minimum average displacement error. We calculate the distance between the predicted trajectory and the real ones. You can see just an average here. And the second one is the minimum final displacement error, which is similar to this one, but now the error is taken directly from the last step of the simulation, the time t. So what was the trajectory, the ending trajectory for the agent? There are other kind of metrics that are used in the self-driving car sphere, like the miss rate, overlap rate, and the MAP, but those are addressed are discussed in our paper, but are, let's say, not so important for the gaming industry, for the visual reactions of the users that plays a game. And then we started to analyze these models, and our analysis basically contains this kind of metrics. First, it is the performance metrics that are on the Waymo dataset, and by that we mean the first two metrics, qualitative metrics, is that our agents can behave realistically according to real world car behaviors. The second is the performance metrics, because you all know the games have several constraints regarding this, and it needs to be real-time usage. And the third metric for our evaluation is how difficult it is to adopt that model and put it in practice to simulation environments and game engines. So we narrow our focus on RECO-AT motion, CNN, and dense TNN, which were one of the latest work from CVPR last year. And this is the full RECO-AT model. I will not get into details. I don't know how interested are you, but you can ask questions if you want, or we can discuss further. In general, it considers the agent trajectories, position, velocity, and heading angle. Here you can see that the history of trajectories are encoded through a convolutional 1D convolutional and an LSTM encoder. Okay, you obtain multiple encoders. Then you have what is important here is that over those trajectories in time, we have an attention model that should give more importance to the agents that are close to your trying to predict vehicle. Okay, the features from the bird's eye view are encoded through the ResNet encoder. Okay, the features are concatenated in the end, and what's important maybe for the presentation is that starting from this input, we have this output, which computes six, which has the last layer, which has 6 decoders, and each one gives you one possible trajectory and its score. So it will give you like let's say 2D or 3D points in the world where uh, the model thinks your vehicle, your target vehicle that you're trying to estimate his trajectory will move in the next couple of frames, knowing his previous trajectory, and of course a score, a confidence score for each. Yeah. This is the motion CNN model, which is very simplified. Now we have like each image, bird's eye reconstructed image, has 25 channels, where the first are the RGB of the scene, the next 11 contains the historical trajectory of the agents to be predicted, and the next 11 are the historical trajectories of the surrounding agents. So you can see examples over here. These are basically those 11, first 11, then the second 11's channel containing the trajectories. So you can imagine that the other objects were moving like that in the last couple of frames. And this is quite important because okay, so about the output, it has, again, it follows the same principle, that it has 6 output trajectories, each one with a confidence. It's quite important because you can see that the model is much simpler than the previous one, having just a CNN backbone here, which is we will see it has 2 options, and it's quite important for an analysis. Then a fully connected layer, and finally it goes to trajectory. So the parameters of the models are and the network is much easier, and it's we are expecting from it a faster inference time. And this is another model, a dense TNT model, which has a similar kind of output, and they just modify a bit the input representation, such now it's not anymore a bird's eye view, but this is directly the coordinates that the data sets are given, and they encode them like an image with polylines. And regarding while we try to retrain these models kind of on the Waymo data set, we observe that depending on the metrics, each model has somehow its advantages and disadvantages, of course. But we observe that for our purpose, regarding the credibility of the simulation with those 2 metrics that we discussed, regarding the trajectories that are observable to any user, the motion CNN performs the best. Also, but this is another kind of thing that was in our advantage, that motion CNN is actually the simplest one for the inference and for the hardware itself to run, because the other 2 models took them more than 12 seconds for a single evaluation of a small batch of 8 cars. Okay, so on the 8 seconds time window. So that was quite important for our evaluation. And we further focus to see if motion CNN can solve our problem, and we can transfer learn from that. And we used for that Carla simulator later with 9 different city maps, different street layouts, roundabouts, circulars, and straight roads, so on, with different lanes. And the observers of this qualitative evaluation were like authors, the authors of the paper, of course, and a team of 11 volunteers from our university that helped us play the simulator and tell us where they find it credible, where they didn't. Very good situation to put on this paper, and so on. And regarding the long-term prediction, which means like 8 seconds in our experiments, we compared the motion CNN using the 2 bones. The ResNet is always on the left of these slides, and the exception is on the right side. Okay, so just to get your attention again, so this was the CNN backbone that had like 2 different models. It has like the ResNet and the exception that we took them already pre-trained, okay, and just reused them. Okay, so in these images, the blue points represent the lane markers that are observed by the agent, while the green ones are the trajectory that is predicted by our model. You can see that in this situation, the ResNet performs very well, not the same for exception. This is for the short term 2 seconds, it performs well again, mostly with the ResNet from our experiments. Okay. In junctions, in intersection, we can see that the agent with the exception performs a little bit better this time, but not significantly. This is another junction which has like a pattern below it. You can see it this is in the Carla city map, where it has like the exception performs worse here, but and this is addressable because in the Waymo data, the car agents never saw this pattern on the street. So that's a problem that we need to address, the cross-main generalization on our future work. Now about the traffic lights, we discovered that our models is not very efficient when it has 60 kilometers per hour or more. You can see that the red, the traffic light is red in this situation, and the car predicts that it should cross the street, which is not a good situation. Limiting the speed of the car to at most 45 kilometers correctly puts this. You can see here red dots, which means that the car should brake and go behind. That's the explanation. There is no difference between the 2 backbones. Of course, and we still have problems with crowded environments when the cars are closed. We had some missing points where the agent crashed, and we analyzed them, and the model was somehow not appreciating correctly the speed and the distance. So we need to improve those kind of things in the next versions. Yeah, regarding the runtime performance, as we wrote more in the paper, we can see that for example, for a number of 50 agents, let's say a crowded environment, we have this like inference time for a batch of 50 agents. And this is for a long run. No, this is for the short-term goal. The long-term goal goes even better, a little bit better. But this is quite important because if you try here to use a double buffering style where you compute for one batch in 2 seconds and then you use the results from the previous buffer, in the last 2 seconds, then it quite fits real-time evaluation. So there will be no miss if you have like a thread, a CPU thread. This is on CPU again, just an end core i5 CPU. So the inference is suitable and for a huge number of agents, even for short-term goals. And the conclusion is that we think that these models can be quite efficient and bring to a real world practice, basically. What means to be done further is some improvements that we observed, and I showed them to you, but we should also analyze how it helps cutting the development costs over time, and because this is quite not very trivial to evaluate without working more closely with the industry. And for those which are worried about how would I put this in practice, how in my game or something, we have everything open source, and there are also the TensorFlow and PyTorch C++ APIs, which can basically help you with putting those the inference embedded in the games themselves. Okay, thank you for attending, and questions now, if you have some.
Thank you very much, Professor Ciprian. It was very, very interesting work. And thank you very much for providing the source code as well, as usual. It's very common in your work. And I know, do we have 3 minutes and a half? Do we have some, maybe 2 quick questions? Yeah.
Yes, guys, do some questions. There's a nice opportunity here to share. Just a super cool idea indeed. Will you imagine that maybe you could use the same approach for different kind of transfer learning? Because, you know, cars is a well-known domain that you have this kind of models. Maybe you imagine that other domains you can use the same approach. What's the challenges to the other domains? Do you imagine?
We also publish something similar for pedestrian agents, because there are a lot of data sets and models that are well studied in the literature for predicting how people will behave on the streets and so on. These are like so the challenges in applying this kind of things is where do you get the real data from? And it's like for pedestrians and vehicles, the domain is so well established. I mean, there are like 3 or 4 top level papers that appear in the conferences and with open source code and trainable models and so on. So you can take those one and use in your products, like we did for this transfer learning of methods to games. But I don't know for the other kind of fields, because it depends on the interest on the field of the subject. Yeah, that's why it was so let's say easy to take the vehicles from the literature, self-driving cars, trained models, and to play with them. I for example, if someone would try to make a games with agents like animals or something, who will provide those kind of data and models? Because that would be.
No, but I think it's super clever idea, because the models are there just to try the technique to transfer, and I believe that more and more models are available. You can apply this technique for the different fields. Super clever idea. Congratulations.
Thank you.
I don't know. So guys, you are here just to collaborate and share. Don't be shy. Okay, participate. The workshop is for us. So, and Christian, what's happening now?
Right now, we finished the first part, our first paper. And thank you very much, Professor Ciprian. And if you have any questions, you have more discussion, you can go to this Discord. The link is on chat. And if you're already there, there is a channel for discussion. We are like a little bit like 10 minutes delayed or so. So let's make the coffee break now. And the coffee break is supposed to be 10 minutes, but let's make 5 minutes. So 5 minutes of coffee break, and then we come back with more or less on time, like 5 minutes late, but still.
Yeah. Thank you. Take a coffee.
A coffee and a water, and see you in 5 minutes, okay?
Yeah. See you. Hi, Harris.
Hello. Yes, you can hear me.
Hello. You are not. You arrived a little bit late. You don't have
Yeah.
the opportunity to introduce you.
Yeah, I'm sorry I was late. I had
No
like
problem.
classes.
Where are you from?
I'm from Romania. Actually,
great.
I'm a colleague of Ciprian Păduraru, who presented just earlier.
Perfect. Yes, true. Super interesting work too.
Yeah.
Because you are not in the previous one too. No. Yeah, you are in this blockchain technology stuff. Blockchain is a buzzword everywhere. People try to put blockchain everywhere.
Yeah, it is a bit of a challenge researching in the blockchain area because of the buzzword effect.
Yeah. You don't have a lot of bitcoins to.
Yeah, no, we're not.
Not
we're not in the
Bitcoins.
Bitcoin business.
Okay. Sure. But you are more for the side of game or more of side of blockchain, and what are your domain?
Well, we actually researched previously. We have a work that I'm also referencing today about how we could use blockchain in IoT security, because I actually rather research IoT security.
Okay.
And then I thought, okay, what if we use this blockchain solution in IoT security, and it was interesting. And then I worked with actually Ciprian Păduraru in okay, what if we combine blockchain with gaming? So it's like moving from one to another. Yeah.
Yeah, Harris works with IoT security, huh? You can catch him too.
Yeah, I guess.
Because Jan works also with IoT and software engineering.
Yeah.
Hello, everyone.
Hello.
Very quickly, break. So maybe we can resume workshop. And I see that so the next work is enhancing the security of gaming transactions using blockchain technology. I'm very curious about that. So the floor is yours. I believe Raris is gonna present. So go whenever you're ready.
Yes, 1 second. Let me share the screen. 1 second. Just 1 second. I have two preferences. Sorry.
No problem. But Chris, you have to stop yours, maybe.
I stopped already.
Okay. Oh.
He said it. He'll be back.
He'll be back. Yeah. But in fact, you have several interesting papers, and I'm not say surprised because the topic is cool, but honestly, better than I imagined. Super interesting papers.
And different papers with different fields, different domains. Yeah. Very nice. There you go.
Okay. Slideshow from the start. Okay, so hello, my name is Raresh Krista. I'm from the University of Bucharest, and today I'm going to present to you a paper that I wrote alongside my colleagues Ciprian Păduraru and Alin Ștefănescu about enhancing the security of gaming transactions using blockchain technology. So as an introduction to these two areas, online video games have become one of the biggest entertainment markets in the industry, both in terms of consumers, but also in financial terms. One of the newer forms of video game monetization are microtransactions, which generate a large share of the revenue for current video games that implement it. Most of the games are, however, part of a rather closed off transactional market, meaning that assets in this microtransaction market can be bought and transacted only within a single game and only between gamers of that specific video game. Now, in light of such limitations, gray market vendors have appeared against the terms and conditions of video game developers and publishers, which basically what they do is allow gamers to sell their in-game assets for the credits that these vendors offer, which can then be used to buy assets in different video games. Some examples may be, if you have heard of before, buying World of Warcraft coins. That was a big scandal back in the day. Now, the second part of our research is regarding blockchain. So blockchain has been a rapidly growing technology that found many applications in security-intensive use cases, especially in fields with high-risk information like financial services and medical services. The blockchain field is currently dominated by permissionless types of blockchains with strictly governed solutions, which do indeed provide some anonymity to the users. Some examples are generally the cryptocurrency markets, which are generally permissionless, so anybody can join them. However, many enterprise use cases require being able to identify and authorize the user and of the user of the distributed ledger, and to be able to audit the transaction log. Context research idea will source blockchain specifically built on fabric, which I will which is acting video game assets between vendors.
I think that there's some issues with your connection, but but I think now it's better.
Oh, okay, sorry.
Go ahead, go ahead.
So about the challenges that we found in in this particular research area is that the providers that currently exist are described as third-party solutions. These are generally closed source and offer, and in order to access them, you are supposed to integrate with this third party, which can create problems regarding the competition between different providers. So for example, all of the members of the industry, publishers or developers, need to trust this third party in order for them to be the blockchain provider. And such it limits the of extension to the entire video game market. Another problem to current solutions is that they generally use a public blockchain solution like the Ethereum mainnet, which, while it's validated as being a quite rather stable blockchain solution, it is also a disadvantage since transacting on Ethereum is requires very high transaction costs and generates latency in the process. And finally, this is more of a current industry issue, that blockchains are generally more associated with pay-to-earn video games, which are a type of video game built on top of a blockchain solution. So sort of wrapping the idea of the blockchain inside a video game, rather than an actual video game that also implements this technology. So this pay-to-earn genre has been criticized as they are seen as toxic by the community. And the solution that we are currently proposing isn't targeting this genre, but instead it targets mainstream video games and their implementations of microtransactions without transforming them into into a play-to-earn model. So some prerequisites for implementing such a system: we defined the market or markets of video games as in-game sections that allow users to interact with the available content of the video game. Secondly, we defined the developers. In general, the term developers refer to the company or group of people that have actually produced the game. While our definition may include these people, we are broadly referring to any content creator that produces assets for a specific video game. These assets may include maps, levels, scenarios, etc. So these might include the original developers, but also third-party content developers. And of course, this content has to be published in the video games marketplace. Finally, we define the users, which are in essence the gamers that interact with and consume the content from the marketplace. In the current game design philosophy, a lot of users are generally prosumers, so they're both consuming the video game and producing for it. So the assets that one user may own in a game, they can be also transacted through the blockchain for assets that are compatible with other video games. So basically taking the value and from one video game and being able to reuse it in another video game. Now, in order to exemplify a bit our architecture, we defined some use cases that we would like, that we actually also implemented. These use cases are generally already available in video game marketplaces, and our solution wants to describe that all these use cases are still available in our project, but with the enhanced value of being able to shift the value around in the video game. So we have developers pushing assets to the marketplace, users buying or listing on the marketplace, users transacting among themselves, creating an auction house on the market, so users can purchase and sell products, assets in that way, and finally, statistical and data mining modules. So the blockchain solution we identified as being very close to what we wanted to achieve is Hyperledger Fabric. This is an open source permissioned blockchain. Some of its main features are its unique identity management, access control, and the membership service provider feature, which is an important part as it allows the identity of network members to be recognized by the blockchain server without disclosing the private keys to each other between the members of the blockchain. In the terms of Hyperledger Fabric, we have chain codes, which are actually the smart contracts behind this blockchain. And its advantage is that these smart contracts, chain codes, are written in Go or JavaScript or Java. So unlike other blockchain providers, they don't use their specific language. They use an already known development language. Finally, the members of the blockchain are grouped in organizations, which are generally used in order to replicate real separation of business logic between different organizations. In our use case, this means that we find separate companies, separate publishers, and separate, let's say, departments inside of those companies. And this is important as our main business case involves organizations that would also need to have separate information. So talking about companies that are involved in trading, they have probably some trading secrets they would want to keep separate. And finally, we have granular policy specifications, which means that the members of these blockchains can define permissions for creating particular channels, and for each channels what chain codes they can run. So not everyone can run any blockchain operation whenever. So there are some rules that can be implemented. As such, our system members or actors are described here. First of all, we have the end users or the gamers, which play different video games, and the video game developers that develop the video game. And finally, the third-party content developers, which can also be the gamers to create the video game. Now, the important part here is the certificate authority. This is a component managed by our game blockchain framework, and it's used in order to allow anyone to validate the content and the actions that they are going to make on the blockchain with this particular certificate authority. How our protocol works is that every transaction or every interaction between the seller and the buyer is intermediated by the ledger. So the protocol ensures that the agreed price and characteristics of the data to be transferred are not changed between the offer to sell and the end of the transaction. Here, this is a sequence diagram where we describe a bit of this process. As an evaluation, the thing we're most interested in validating was the ability to implement such a system and not create an overhead to the existing video games. So we tried to query our system and identified that we really had a very good performance. The reason for this good performance is the fact that we use this permission blockchain and also private blockchain for this use case, which drastically addressed one of the main concerns with blockchain, which is that it can be quite slow because of the size of them. So we have this data and a bit explained in our paper. Now, some of the takeaways of our architecture is that it furthers the solution of implementing cross-developer and cross-publisher asset transactions. Using a permission blockchain, a permission private blockchain, but can make the transaction costs between become comparable to non-blockchain solutions. And as future work, we have some things that we would continue to address. So first of all, to find some industrial partners we could work this architecture with. Second, it's a general problem of the blockchain, but we would also have to address it, and that is the better ability to remove the data from the system in order to comply with the GDPR and even gain some efficiency. And finally, the economic challenge, which is quite outside the realm of software engineering, in which how would different competing publishers agree to use the same system, and what are the security concerns that each should address for them. So this was the presentation of our work. I hope it sounded interesting for you, and let me know if you have any questions.
Thank you very much, Haris. Was very interesting topic. Well, blockchain in gaming is very controversial sometimes, or when you put NFT too, especially with the end users. But it's very nice to see that you're using for a reason that sounds interesting, sounds relevant. Do we have questions? Because I do.
Yes, super interesting topic. I have one question, maybe, because if I understood well, we're proposing to use a private blockchain or not the public blockchain, say as Bitcoin or different blockchain systems. Because super interesting for me that the latency is small that I imagined previously. So
This is the reason why the latency is small, because
sure.
we adopt in our paper like this private or consortium kind of, where we do not have so many users and so many machines that needs to do that judgment and take the decision. And yeah, so this is one of the reasons.
Perfect.
Yes.
Then there a risk that as the number of users grow, then the latency will grow like in the same rate, like more users, greater latency.
No. So it doesn't grow with the number of users. It grows with the numbers of machines and in the consortium that needs to take decisions. For example, if there are multiple instances that needs to approve the user transaction, that it will grow with those. So it's always a trade-off here between the security of the transaction versus the scalability of the operations.
Okay, I see. Thank you.
Anyone else? You can just speak or write. Up to you guys. I have one question if no one is asking. When in your concluding slide, you say that the solution furthers, correct me if I'm wrong, furthers the objective, furthers, but you didn't specify clearly what can the blockchain, could you expand a little bit on that? What furthers what?
Okay, so until now, the state of the art in this technology implemented in video games is generally focused on the pay-to-earn area, because that's the pay-to-earn area, because that's the area where you can actually have some value for the assets behind. So those games are created in a form to play with Ethereum, which is really a valuable coin. Our project wants to take these concepts, which are quite valid, and move them to a more realistic video game industry scenario. So we don't really have a certain blockchain that gives value to the assets that are built on. Since it's a private or a blockchain created specifically for this reason, but it also allows the publishers to have more trust into this process, since using this ledger, they can, so first of all, because the blockchain, they can always see the transactions that happen, so they can cross-verify each other. But in the same time, since they have an individual channel that they are able to communicate with this main blockchain, they can also know that their private data of transactions between they and their user base will remain theirs, and other publishers will keep their own. So it furthers the technical problem, but it's still bottleneck, maybe because of the economic challenge that I mentioned finally.
Mm-hmm. Okay, I think very interesting. Anyone else? We still have
just a comment. I really appreciate in your paper this highlighted the economic discussion, the economic challenge, because I think it's a nice opportunity to think more deeply on that. And as your infrastructure, it's true, it's a technology, there is architecture behind it, but also this business behind that could be explored. I was super interested in the discussion, and I hope that you can definitely explore further this economic aspect. Super cool. Congratulations, super nice.
So on top of that, just to finish the discussion, maybe because you know much more than me at least about the blockchain, do you know of the game called X Infinity? And because if you know, could you just a little bit, because the prices to enter the game, you used to be like the high price, like around $300, and then it goes down very fast, and people are discussing, okay, is this moral, legal, is it right? A lot of discussion towards that. Maybe you could share some ideas.
Yeah, so I don't really have specific knowledge about X Infinity. I just know that it's one of the games that I was referring to. And indeed, the controversy comes from the fact that basically how one of these games are played is, let's imagine Pokemon, like the video game Pokemon. If you have one Pokemon in that video game, is in such video game such as X Infinity, that Pokemon is actually an NFT, which has an associated value. So if the game generates it for you from creating a new account, it's probably something very low value. It's like just starting on. Theoretically, you can either buy different Pokemon, which are more valuable, and in theory, at least, playing the video game should affect the value of said Pokemon. So if it's a Pokemon that, due to your gaming abilities, wins a lot of matches, it should grow in value. The controversy is that even though your Pokemon may grow in value relative to the other Pokemons in the video game, if the underlying blockchain structure, for example, Ethereum as a whole, goes through a dip, then inevitably your Pokemons will also go down with the said dip.
Mm-hmm.
So you may actually be the best in the game and still go down in value, in the value of your assets.
Yeah, because that's a good reasoning behind the problem. Yeah, well, there's a lot to discuss about this, but I guess we can move on. The next talk and our last talk before our keynote. The paper is called Towards Agent-Based Testing on 3D Games, of 3D games using reinforcement learning. I'm very curious about that too. The floor is yours for, I believe,
Raihana.
Raihana. Yes.
Can you see my screen?
Yes.
Yeah, it's perfect. Go ahead.
Okay, so good afternoon, everyone. I am Raihana Firdaus, and I am here to present our work on agent-based testing of 3D games using reinforcement learning. We have done this research with my colleagues Fitsum Kipetiu, Davide Prandi, and Angelo Suzi. We are from FBK, Italy. And I would like to start with some introduction of the game testing, why testing is important, and the motivation of automated testing, and particularly reinforcement learning, why we can use it, and some recent work on reinforcement learning. And then I will go on our proposed methodology in details and the evaluation, and finally I will give some pointer on our future work. So let's start. So the video game industry is very big, and it continues to grow and very competitive. So testing is utmost important here to keep in the race, and so the releasing excellent quality games and ensuring a top-notch user experience is very significant. And till now, they mostly rely on manual or script-based approach, but the games have increasingly more interactive and complex with the advanced technologies. So playtesting with human participants alone or some scripted approach has become unfeasible to say. So playtesting with autonomous agents has great promises by accelerating the process at a scale and breadth. But there are some challenges here. First of all, to achieve high coverage in a large combinatorial space and possible events and transaction is very challenging. And also, some functionalities can only be reached through a specific sequence of events. So this means that with simple random exploration techniques, this may not possible. This is very challenging to reach these goals. So smart exploration strategies are needed there, and reinforcement learning based approach have the potential to significantly improve the automated game testing, as they have the capability to interact with the dynamic and uncertain game environment without any explicit need of modeling those games. And our work also in use of reinforcement learning. So I want to share some lights on the recent work on reinforcement learning. Basically, the recent work focused on constructing intelligent agents that can play the game. So it's like reinforcement learning agents has achieved great success in playing the game, starting from totally random tracks to finishing the games with sophisticated skills, tactics, and even superhuman skills. For example, we have seen from Google DeepMind the game of Go. It's like a few years ago, before they trained the agent which beat the world champions in the game of Go, and also they carry on with more complex real-time strategy games of StarCraft. And also we have seen from OpenAI the multiple online battle game Dota 2. They have trained some agent to play the end game, and the results is amazing. So inspired by their work, a few research work has investigated the potential of using reinforcement learning beyond the game playing, so towards in the direction of more like bug finding and maximizing the coverage of the space of the environments. And our work also in this direction, but we actually focus mainly on checking the feasibility of using reinforcement learning in testing, and also providing some functional coverage in the 3D games. In particular, providing coverage, we focus it more because defining a common notion of coverage for 3D games itself is a very difficult job, and due to the diverse characteristics and complexity of the games. So here we in our approach, we do not optimize any behavior policy or sophisticated gameplay skill, but rather we deploy an agent who can advance in the playing in the games and also explore the game environment. So our goal is to identify some coverage metrics significant to provide some coverage in the 3D maze game, and we also focus on the strategy to measure them. So before going to the details, I just spent 1-2 lines about the background of the reinforcement learning. I know everybody knows already that, but just to conclude. So the reinforcement learning is mainly suitable for decision making, for the problems that involves decision making in successive cases, and where the objective is long term. So here the agent concerns about learning the optimal behavior in an interactive environment by trial and error, using feedbacks from its own actions and experience. And also in this reinforcement learning phenomena, we are particularly focusing on Q-learning because it's a model-free reinforcement learning algorithm. And we are interested in this Q-learning because most of the games, it's very hard to depict a specific model. So this Q-learning can be useful there to directly training a value action function that knows the value of each action state pair, and that can be used later. Now I want to talk about, in particular, our methodology for reinforcement learning for testing of the games. And before going that, I want to give an example of the environment that we actually focus on for the clarification of also later discussion. This project actually, this research work actually based on in the scope of the project of a European Union project named ASE4Games, which is focusing on the verification and testing of the extended reality system. And in this project, we have already a game for experimenting with intelligent agents. And this is actually, this game is called Lab Recruits, and it allows the definition of mazes where a set of rooms and corridors connected by the doors, and each door is opened by one or more buttons, or each button activates one or more doors. And this scenario could be further enriched by adding different furnitures like table, chairs, or other lab equipments, and also simulating some fire hazards to some danger, to replicate some danger situation. And the player goal is to find a path to reach a certain room by opening the doors in the correct order. And this game can be played by both human and artificial intelligence agent. And this is this image is from one very simple level of this game, just for suitable for understanding. And here we can see that these are a couple of 3 or 4 rooms, and they are connected, as I was saying, with some buttons and doors. And the goal for the agent to reach this door, open this door 3 with specific connected buttons, and reach this start position. And these are the logical connection between the buttons and doors. So for example, door 3 is connected by door 2, button 2. So we formulate this playing of these games as a reinforcement learning work, and the agent has to learn the optimal policy by trial and error. Here, the environment, obviously, the game under test, and the state we represent is as the agent's observation of the environment, and the action are the set of possible decisions that the agent can make in a given state, and the reward would be the feedback by the action the agent is taken. But this type of modeling is not trivial. There are lots of challenges, and it is more challenging even playing most Atari or board games, because it involves a vast amount of critical thinking, problem solving, and path finding. So I can highlight some of the challenges. For example, the most significant one is the imperfect or partial information of the environment, which adds a high amount of complexity in learning. For example, in this level that I have shown before, the agent is here, and if the door 1 is closed, the other entities behind the door is unknown to him, and this is one type of partial information, and another information is that, for example, let's consider the agent is inside here, these unknown entities. It can open the door 1 and it goes there, and somehow the door 1 is closed. And in that situation, if somehow it presses this button, can you see my mouse pointer?
Yes.
Okay. So
Well.
if it press this button, then it opens the door 3, but the agent is inside this room. He has now not aware of the information that door 3 is already open. So this type of partial information really affects the learning, and it affects particularly in distribution of the rewards. So basically placing this button should give him some reward of opening the door, but as it is unaware of the situation, it is not getting the reward perfectly. So this is one situation. And another issue is the increasing number of the state and the action space. Sometimes in some works, the states are defined as the 3D positions of the agent at a given point, and keeping track of those visited counters on a continuous space. It really sometimes it really quickly becomes intractable, and these games are long time horizontal games. So in this case, this situation is very high. And another issue is the delayed and sparse reward, which is like is really a hurdle because in case of the environment where there is dense reward, the agent can frequently get the feedback of its action, so it can learn quickly. But when in a delayed or sparse or non-existing reward environment, the agent doesn't know which action to take because it doesn't get the feedback properly. For example, in these small games, if we consider that agent press a door, if the goal is to open door 3, it won't get any reward, since if it doesn't open door 3, all the actions it will take pressing other doors and buttons, it will always get 0. So it's very hard for him to understand and learn the sequence of the actions to take to successfully fulfill its goal. So these considering these issues, one measure we have to follow, that we have to be very precise and very careful about the definition, to define the states and the actions, and also to take some measures to formulate the reward function to satisfy the coverage goal. And we also in this work we follow these, and we to represent the state and the action, we want to stay at a very high level of abstraction to limit the state space. So in this sense, we consider to take particularly the entities. And the entities mean in this environment, the doors and buttons and other lab equipments. These are the entities. So we consider only the entities that can be helpful of taking an actions. So for example, in this case, an agent can only interact with the buttons to open the doors. If there is any chair there or a table there, that is not an interactable entity, because that is not helping him to achieve his goal. So here we construct the state from agent's observation of an environment at a certain moment, and we only consider the entities that are interactable. So in this case, we only consider the buttons and the doors, and with their properties that are important. So in our case, it is important to check that whether the door is open or the button is already pressed or not. So we consider those properties, and we prepare the actions, we prepare the states from an observation from of the environment at any given time, and we take the actions from those state. The actions are the interactable entities. So if, for example, in this case, a button is an interactable entity, so these can be an action. For example, in this at the beginning, let's say the agent is in a state where all the buttons and doors it can see are false because they are not pressed. And then let's say that the agent press button 1, and which opens some this door 1, which opens some with this act, some other buttons and doors behind this door are visible to the agent, so it reaches another state where it can see the other additional entities and the properties. So this way it goes on. And in case of reward function, as I was discussing before about the delay or sparse reward issue, one common technique is to formulate the reward to make it more dense. But it is this policy is very specific to the problem. So every time we change the problem games, we have to be very specific about that game to make it dense. So we use another generic approach, which is to use the notion of intrinsic curiosity, the agent's natural desire to explore the environment, to understand new things, and to reduce the uncertainty about the environment. So we provide incentives to agent for exploring new states, while penalizing him for penalizing it for exploring previously visited state. And in this case, in this way, we composed of the result reward is computed based on what is the distance of the current observation of the agent from the most similar observation in the memory, and the agent receives a higher reward of seeing new observation. So in this way, it is curious about learning or going to new places. So new places in the sense that going to the different places of the environment. And this, as I was saying, this tactic is more generic, and it can be applicable to diverse environment. And with this state and action representation, we used an agent-based testing infrastructure, which is already developed in our project to interact with these game laboratories, where the intelligent agent can follow the goal-driven planning, so it knows that it has the navigation capability, and we just only rely on the agent to provide him high-level goals. For example, to press the button or to go to some door, and it can able to find the path to solve it. And we use Q-learning solutions, and for the problem we have this simple example, we use the tabular Q-learning to make it the design simple, and we name this proposed at curiosity-based reinforcement learning and implemented in a prototype tool. We call it RLBT, and this is open source. And now I want to discuss about the results, initial results that we have. So the results, the research questions, we have formulated some research questions to guide the experimental evaluation. The first one is we want to, the research question one is to how suitable the reinforcement learning best approach for automated game testings. And the second research question is more to the coverage. We want to check that how suitable it is for providing functional coverage in the context of game testing. And with the proposed curiosity-based RL solution, we compare it with two alternative baseline solutions. One is the sparse reward RL, where the classic RL reinforcement learning approach with only the intrinsic sparse reward. That means the agent only get rewards when it achieves the final goal, otherwise nothing. And with the pure random one, where the agent take the decision randomly without any learning. And the experimental setup is that we have the laboratories game as the system under test, and we run this solution on different levels of laboratories. The one is here, it is a straightforward rooms of 8 rooms, and 32 buttons and 16 doors are distributed across these 8 rooms. And this layout is very simple, so that the agent can fairly easily spot the buttons and eventually observe their effects. And we also have another couple of this type of mazes where we have high number of buttons, and which are like here 19 buttons and 14 doors are distributed across 14 rooms connected by long corridors. And this is physically the space covered by this level is significantly larger, and the agent needs to travel a long distance to get from one entity to another. And this poses a different types of difficulty, because here it can happen that the agent presses one button and but it opens a door which is very far away from him. So he doesn't aware of the situation that the door is already open. And we have some, I'm not going to the parameter settings in details, but we have used some suitable values of the parameters. And so let's go to the results. And the result is, first of all, we evaluate the goal-oriented one. It's related to the research question one, how feasible is RL for gameplay testing. And here we give the RL agent to reach some destination. So for example, reach in case of 8 rooms, reach the final rooms. And we found that the reinforcement learning agent is able to efficiently learn the optimal sequence of actions needed to achieve that goal. And the second one is coverage-oriented results, which is more related to the research question 2, how feasible it is to use reinforcement learning in providing functional coverage. And here, as I was saying before, that it's very difficult to find the significant coverage metrics. And we try to find some coverage metrics, particularly for these games here as an example. And here we the first one is the entity coverage. So entity coverage is in this particular game, we are interested about the entities. So we have like some doors and buttons which can be pressed or not pressed. In case of buttons, and doors open or closed. So the coverage goal is for the agent to see or observe all the entities in all its possible properties. So in this case, in this small example, the agent has to see all these in this table, all the states, all the properties in this table. Of course, when this is an example, but when we think about a large maze, this goes and it's become a very large task for the agent to cover. And another one is the entity connection coverage. So here we, as I was saying before, that in the game we have the connection between the doors and buttons. So one button may open a couple of doors, while one door may be opened by a couple of buttons. So these connections, and we name it entity connection coverage, just to check that whether all the connections between the doors and buttons are successfully satisfied. So the measuring this quantity value is not as straightforward because of the partially observability issue. As I was saying that the agent press a button, but he may not aware of the situation that the door is open because of this partial visibility. And so we follow a probabilistic approach to measure the entity connection coverage ratio to and this is the experimental result from the training session of per episode coverage. And this is the results from the 8 rooms, and this one here for the large maze. And we saw that in case of a small room, the result is very good, and also it shows significant improvement compared to the sparse and pure random one in case of the complex and large mazes, in case of the entity coverage in per episode. This is a test example which is performed over the optimized Q table, which is trained over some sessions, and it is shown that curiosity-based approach has the high potential to obtain better coverage in large and complex environments. And also, this solution has the potential to discover the inconsistency between the design issue. For example, we have while training, we have encountered the logical placement of one button, and this type of information is very, very, very valuable to the game designer. So in conclusion, just to summarize, that our objective was to assess the suitability of reinforcement learning for the purpose of testing of 3D games. And we propose to remain at a higher level of abstraction while defining the states and actions, and use curiosity for the reward formulation so that it can be it has the potential to be generic and to be applicable to other 3D games with simple modification. So our goal is to propose an idea which can be used in case of 3D games for testing and for coverage. And the results are quite encouraging and it's paved the way for further experiments with complex complex levels of laboratories. And we are actually doing that with very large levels and complex distribution of the rooms, and also with other games with more complex interaction space. And it could be easily adapted to the testing of the other games, provided that the implementation, it has the implementation of the testing agent interface. And as to some pointer for our future work, as I was saying before, that we were applying it for other large levels of laboratories, and also we are applying it to other 3D games from real world, which is a Space Engineer, which is also has implemented the navigation space in our project. And our future goal is to perform a comparative study to assess the effectiveness of this tool with respect to other testing approaches, for example, model-based testing applicable to 3D games. And that's all, and happy to answer your questions.
Thank you very much, Raihana. Very interesting work. I would love to discuss it more, but we are out of time. Guess what? Maybe one quick question?
A tricky one. Why you, or maybe a tricky one, why you discuss to limit your work to 3D games? Why is especially to 3D games?
No, actually, it's not limited to 3D games, but we started 3D games because it's the most complex and most interactive phenomena field right now. So we just want to test the feasibility of the approach, and of course, it can be applicable to other places.
Yeah, for sure, it's more complex environment. Absolutely. We have our lovely keynote right after, but can we have like a quick 5-minute break? Then we go for that?
Of course.
Perfect. Yeah. Thank you very much, guys. Sorry for the delay, but you know, this is hard to be right on time. Okay, 5 minutes.
Okay. But if you are here, no problem. You can, the room is for you. You can use as you prefer. But just to, I'm well here. And just to say, Heiner, congratulations. It's really super interesting work. And Cristiano are doing something similar. And you know, you have two papers around the same topic. So Paulo also work on similar topics. So you have a lot of intersections to collaborate. And
yeah.
But Heine, do you work with Antonio too? Antonio Bucarelli? Or no?
No.
No. Because Antonio participated a lot in last workshop. Antonio Pucchiaroni. I think it's the same place are you working on, but just in a coincidence.
By the way, I have read your survey paper, I think some recent work on the video game testing.
Yeah.
And it's very interesting to...
Serious games, usually yes. He participated last year, and now he's organizing the gas workshop at ICSI too. So it's, I think he works in the same foundation that you are. So interesting. Nice that you. Interesting that you're not in touch, working together around that. And but for you, what's your biggest challenge in your work? Because as Cristiano also, you are doing some similar approach to try to use reinforcement learning, especially for evaluate balance.
Yes.
But what's your challenge? What you feel harder when you are doing your work?
The challenge is that I mentioned at the beginning, that it's the partial information, imperfect information of the environment. So this makes the learning very complex and tough.
Mm-hmm.
Because the example I was showing, that the agent is not aware of the situation, that is not aware of the impact of its action, let's say. So in this case, it's really difficult to provide specific rewards, and as it's not getting proper feedback, it's really difficult for him to the agent to learn anything.
Mm-hmm. I got you. Yeah, because this is a similar issue that you are facing too, because sometimes to model these rewards are super challenging.
Yeah, it's actually the main idea is that it's based on it learns based on its feedback. Mm-hmm. And if it is a stationary environment, for example, in one glance of a board game, the agent knows has all the information it needs to maximize its rewards, so it can learn. But if it is like this partial information or imperfect information, it really hinders the learning problem, and it yields a very average or worse learned solution.
Mm-hmm. Yeah, you are in the same boat, trying to think better ways to use reinforcement learning to support testing. I agree with you. Reading your paper, that is it's a technique. There is promising maybe results, but it's a long way yet to do a lot of stuff to understand how to use this technique more. Can say not just usefully, but more smoothly. Cristiano, let's go, Cristiano.
Okay, thank you very much, guys. We are back for our lovely keynote. Jan's going to make the presentation, please.
Yes. So we are very lucky and happy to have Carl, who will talk to us about video game and their history. So Carl is actually associate professor at University of Montreal in Montreal, and in the Department of Art History and Cinema Studies. I think I translate correctly in English. And he has been actually working a lot on game and the history of games. And he wrote actually a book on PC Engine, or the TurboGrafx 16 for those who knows. And that was his first book, but I think you are working on another book, are you?
I'm working on an anthology on immersion, and so VR, but not only VR, games, museum exhibits, etc., etc. So yes, this will be coming out at Amsterdam University Press in 2023.
Okay, cool. Congratulations. I'm waiting to read that book. So, Carl, please, the floor is yours. Thank you again.
Thank you so much, Fabio, Cristiano, and Jan, for inviting me. This is very interesting for me to get acquainted with different disciplines, and I'm very impressed with the depth and the excellence of the papers that we saw this morning. We're going to be landing on a different planet today, talking about video game history, but I hope you can see there are some obvious bridges that we can build, and there's obvious use for programmers and computer scientists in doing better game history. And I hope that I can demonstrate that today through the study of the PC Engine corpus. And I will start literally with a landing sequence, a capture of the first level of a game that you probably don't know. And just, can we all see the screen right now?
Yes, perfectly.
Thank you. Oh, sorry. Just to make sure, I'm going to share it using the Zoom as a, I forgot to use the optimization features for Zoom. So I just want to make sure that I'm doing justice to this great game. Let me share that again with you. So there we go. So, did it play out properly? It was choppy at first here.
Yes.
Okay, great. There will be more game excerpts coming up in this presentation. This is called terraforming, and let me start my slides from the beginning. Can you see full screen?
Yeah.
Thank you. So this is terraforming, or as it was known in the United States, Sid Mead's terraforming. Now, you probably all know Sid Mead because Sid Mead is responsible for most of our science fiction imagination, from Tron to Aliens to Blade Runner, of course. And he collaborated directly to create terraforming. And you can see how inspiring his designs were to the creator, but he was involved directly in the creation of some of the creatures. And so it's very puzzling to me that we don't know Sid Mead's terraforming. And that's just one illustration of a more general point that I'd like to make with all of you today. It's that we don't know video game history all that well, to be honest. And it's a bit of a tragedy. I know this game because I wrote, as Jan mentioned, the platform studies book on the PC Engine and TurboGrafx 16. As you can see with the subtitle, there's a lot of components there. That's because the platform constantly evolved and changed names. It was somewhat a shapeshifter. But it's known and it's remembered for being one of the first, well, the first CD-ROM extension was released on this platform by Enishi and Hudson in Japan in 1988. Years before the PlayStation had the same format. If you're interested in the platform study series, there are many other books in the series. They have about a dozen right now, and it's always starting from a well-loved and known video game platform. Arguably, the PC Engine is the lesser known of the bunch so far, but you've got a lot of diversity in the books in the series so far. MIT Press is very proud of this series, and it's very successful, with more books coming on the Commodore 64 or other platforms. The reason I know this game is because, yes, I own a TurboGrafx 16 when I was a kid, but you only knew half the story when you owned the TurboGrafx 16 because it was somewhat a failure in North America. In Japan, it was a whole different story. As you can see, this beautiful design, miniature platform, very small, very sleek, still very, like the Japanese people are still very proud of this platform. It's a landmark in their history. It was a success in Japan and in parts of Europe. It used this very small cartridge system. They call them U-cards. Been used by other systems before, like the Sega Master System, but you could cram games like Street Fighter 2 on U-cards, and this is what they call a credit card sized format. again, this was all very striking in 1987. It was like the most technologically excellent platform you could get your hands on. Today, you can get access to these platforms. This is the last version that was released, the PC Engine Duo RX, which I hold in my hand right now. And thankfully, I bought mine before the price of retro gaming exploded. As you can see now, it can set you back over 600 Canadian dollars very easily. And yeah, that shows that the retro gaming community is really, really enamored with this platform. And it's 700 games that are mostly out of view in North American history of video games. It was produced by NEC, which is pretty much the equivalent of IBM at the time in Japan. It's responsible for the distribution of 50% or more of personal computers on the island. It was designed by Hudson Soft, which was a prime developer for Nintendo, the Nintendo Entertainment System and Famicom system. You even saw the release of a mouse accessory on the platform, and that's because probably of NEC's influence. You had a wide variety of games on the PC Engine, not only shoot 'em ups and platform games, but you had adaptation, a lot of ports from computer games like Lemmings, for instance, or A-Train, as it's known in Europe and North America, or A3, as it's known in Japan. Complex simulation, you kind of need a mouse to play it, and it shows the scope of the games that you could find on the PC Engine. Did you know that A-Train was the best game of 1992, according to PC Magazine? We don't know video game history all that well because we've forgotten even the best games from recent history. And yeah, as you can guess, this is a point I'm going to make up throughout this presentation. I want to defend this idea today with you that the PC Engine fan community actually holds the key to a better future for all gamers, that the diversity of experiences and of gamers that you encounter on the platform actually created something very interesting in terms of showing the potential of games and all that games can be. So this is titled Video Game Histories in the Wild, a Panorama. I'm Carl Terrien, and you'll get to know a bit more of my work throughout this presentation. I'm going to introduce a non-linear guided tour here of this digital park, trying to map game design and code through my collaboration with real programmers, capturing glitches. You might have noticed in the first clip that I showed that there was some glitchy output there. We'll dig into that in a few moments. We're also going to be looking for real gamers, and as you'll see, this will connect with ongoing debates right now in gaming culture that are very prevalent in what we call the cultural wars. Trigger warning, there's a fair bit of graphic horrorism and other techno-fetishisms in this paper. There's some feminism and queer studies, and there's also a little bit of geek nitpicking. We don't know game history. I just want to bring that point home one more time before we jump into all these wonderful exhibitions. On Moby Games, which is the most one of the oldest collective databases made by fans of the medium, they have documented so far over 300,000 video games. Now ask yourself, how many of these games do you personally know? I've been working on game history professionally for the last 12 years, and I probably know, I don't know, 3,000, 4,000 games, something like that. I started working on game history because my supervisor back then, Bernard Perron, when I was doing my PhD, asked me, Carl, do you want to write a paper on the history of horror games from my anthology, Essays on the Fusion of Fear and Play? I'm like, okay, let's try it. It's not a very good paper. It's a decent paper. But that's when I got the interest into video game history to the point of doing a postdoc and building part of my expertise on the topic of video game history. And of course, I'm not the only one working on that topic. But we don't know game history all that well. So when I wrote that paper, I didn't know Ayaku Monogatari, which is a very important horror fiction game built in collaboration with a very famous Japanese horror fiction author back then. I didn't even know Jantei Necromancer, which is the fifth game released on my platform by Hudson Soft, and to my knowledge, the first game using licensed content from Geiger, the creator of the alien creature that you probably all know, of course. Now, this is interesting because we're in 1987. This is still at a time where Nintendo is trying to convince parents and everybody that video games are good and healthy and that there's no problems with games and that they're family friendly and you can buy them for your kids. Enishi and Hudson Soft decided to address a larger spectrum of gamers, including more adult gamers, even though in 1987, the average age was still pretty low. I also wrote this paper on first-person shooter games because I'm a huge fan of that genre specifically. And again, the same conclusion is when I wrote the paper, there was, we still don't know that history, even of this most popular genre. We don't know that history all that well. For instance, before id Software claimed the genre with Doom and Wolfenstein 3D, 10 years before, you had games like Capture the Flag by Paul Ellison, and it's basically a free, smooth scrolling 3D game where you have some of the modes that are well known in first-person shooter games. Now, this game is on our radar when we talk about FPS games, but very few people have the curiosity to go back in history. Since 1980, there are games that correspond to what we call first-person combat or shooter games, but we all think it starts with Doom in 1983. There's kind of this blind spot that we have a lot of work to do to really uncover. Interestingly, this game from 1983, aesthetically is still very similar to Faceball, which some of you might know because it was released on many, many platforms, including the Game Boy. This is the PC Engine version, and as you can see, it's a FPS, it's a first-person combat game, competitive with up to 4 players on screen. But in a very cute style. It's very, very striking clash, and we'll be coming back to this idea of a cute 'em up in the second part of this presentation. So I want to talk a bit more about something that will be engaging for people working in your field, and you will see that the potential for computer scientists and programmers to help with the creation of better historical accounts is immense, and that this work has already started. We have started to map game design, and this is reflected in this paper called Toward the Visualization of Video Game Cultural History, Grasping the French Touch, that I wrote with Isabelle and Jean-Charles. We wanted to see what's striking about these French games that are well known for being very idiosyncratic, very original, such as Captain Blood, also inspired by Geiger here, as you can see. And so what we did, we encoded 100 games, 100 adventure games, to see if we could find which concepts, which elements of game design are more prevalent. And yes, so for instance, when we study the most prevalent interactive figures or categories of mechanics in adventure games, out of 10 concepts, there are 5 of these concepts that are more prevalent in the majority of our corpus. And so we're starting to measure up and to visualize larger corpora, larger amounts of games that can direct us to refine our understanding of game history, how it evolves, what is original about a game when it diverts from this, the canon and the majority of games. And so we hope to develop this further. If any programmers want to help us, we are always looking for help to do that. But I've had the chance recently to collaborate with John Haycock, who is here today. And we just did this paper for Foundation of Digital Games, and we won the best paper award, nothing short. The sincerest form of flattery, large-scale analysis of code reuse in Atari 2600 games. As you can see, this involves many scholars coming from many different disciplines, and this is the beauty of such a paper. And John, of course, is leading the pack because John has these skills. He's able to inspect code released on previous platforms. For instance, here you have a heat map showing code reuse between the Activision game releases on the Atari 2600 games. For this paper, John retro-inspected nearly 2,000 games, 2,000 different ROM images that we have access to thanks to pirates. And he's able to visualize and make hypotheses about code reuse. For instance, here in David Crane's production, the most famous game, some of the most famous games on the platform, depending on the length of instruction sequences, you can find code reuse in many, many instances. And the paper can find details of what kind of code exactly is reused and for what reason. So this is really giving us a macro perspective on game history, and it can only be done through this kind of assemblage of expertise coming from different fields. And this says a lot about what we can achieve going forward to know video game history a lot more and to include a lot more games into our appreciation of video game history. And I want also to point out that gamers are doing this with much more traditional methods. Game fans, and the PC engine has a lot of fans. In France, the platform was not even distributed officially in France, but there's a huge fan community there. They wrote these 2 Bibles detailing the 300 games that were released in the small credit card format and the 400 games, first 400 CD-ROM games in history, barely known in our historical imagination. Well, this fan community wrote they had a significant engagement with all of these games. They wrote a little critique, a little appreciation of all of these games. And so these Bibles represent an invaluable resource when you study video game history, to have a macro historical perspective on the totality of games that you cannot build. You cannot have the totality of these games by yourself. Some labs and some museums are hosting a collection, but it's very rare to find a complete collection of these games. Thankfully, the fan communities are coming in. And so doing research on the platform, I discovered games that I never suspected could exist. Just on these pages here, you have Annie in the Sky and Annie on the Road. This hero is based on terracotta figurines found underneath Tokyo while they dug up the metro system. Coming from medieval times. And so basically they created a video game hero out of heritage. Also on these pages, you could find Eisho Aniki, or Super Brothers, which is one of the best shoot 'em ups you can find on the platform. From a technological perspective, it's very colorful, very big characters in sprite, but also you can see the originality and you can sense how Enishi and Hudson Soft were not afraid of throwing some adult content in there. And so, yes, this is one of the best shooters you can find on the platform. And not only because some of the enemies are performing a 69 while you play, but there are tons of great qualities. It's very whimsical. It's very humoristic. I really highly recommend that you play Eisho Aniki. So this is what we're doing right now. This is the type of work that the community at large, from academics to fan communities, are doing to help us have a better appreciation of video game history as a whole. Now, I want to talk about something very specific that I discovered doing writing the book, and that involved capturing glitches. You might have noticed in the intro with terraforming that during the landing sequence, there's a lot of glitchy output on the screen. And you might have wondered, is it part of the game? Is it something that was taken when I captured the content? If you found screenshots of terraforming online, you would likely see something like this. And you can see that there's a great discrepancy between the 2 screenshots here. What happens exactly? I captured this segment on my DVD recorder. That's because I come from a school of game studies inspired by Bernard Perron's work. Bernard captures all of his play sessions for work research purposes. And we've been doing this for 20 years in our research group. And so I decided that we need to engage with the material trace of the console and not only engage through emulation and the more recent ways we have to engage with game history. And basically, I discovered that the community here, again, wants to go back to the original material traces in a major way. This is a Twitter publication by Kyle Pittman. Kyle Pittman is a retro game maker, and this post went viral on Twitter in 2015. This opposes what indie developers think retro games look like this very perfect pixel, the perfect square pixel, versus what retro games actually look like. This is a photograph of the same game, The Adventures of Link, on a CRT device, on an analog television, as some of you might know, because some of you are old enough to have grown with CRT televisions. So there's a huge gap here. There's a huge aesthetic difference that might impact your appreciation of any game, really, when you think about it. We set out to find out the source of the glitches that I found in the PC Engine corpus. Before I mention that, yeah, just to say that this is a game from Kyle Pittman, and Kyle has created a CRT simulator. So this is not a real cathode ray tube. This is a CRT simulator that you would apply on your modern computer on an old game, and it seeks to recreate the aesthetic effects associated with old television. So that shows the length that the community is willing to go to re-engage with the original material and aesthetic traces of video games. As I mentioned on my platform, we saw this glitching artifact, and it was something very peculiar because I didn't remember it from my younger self. And for a console that prides itself on graphics, having so much artifacts on screen was something very interesting. Like, how come we didn't see it back then? What causes this glitching? Is it maybe caused by decay? So I set out to go into the specific literature made around these imaging technologies, such as Salcher's classic electronic displays and computer graphics. And of course, they don't focus on the glitches so much as all the other complicated knowledge you need to know in order to make graphics on the system back then. I enlisted the help of an electronic engineer who studies right now at ETS. So Cristiano, perhaps you could corroborate this in the question period, but he tells me that they don't study anything of the sort. They don't have the time to study in an undergrad courses. They don't have the time to study these old imaging technologies. So it was a big mystery what caused the glitching effect in many games of my platform. And so basically, we confirmed that it was not decay of the phosphors or the cathode ray tube itself, because we could find traces in the original manual of the same game, Vague's Tactical Gladiator. We found, as you can see in the background, you can see the glitching effect was already there in 1990 when the game was released. So we tried to diagnose through many different tests what was causing this, and we ended up finding that it was the dithering. Dithering is a strategy used by graphical artists back then to create the illusion of more colors on screen, like to have these fake intermediary colors by having these complicated, intricate assemblage of black and white pixels, or any two colors, really. This is the condition present when the glitch appears in every scenario. And so just to corroborate this idea, I invited John Aycock again. John is able to write Python script, and he's able to master old programming languages. And so basically he wrote a program, and we burned it to CD because these old platforms didn't have CD protection. They're the first CD platforms. You can put any CDR that you put in there will work. And so John created this video artifact test program for me so that we could corroborate the hypothesis that this emerges in the dithering pattern. And so what you're going to see is a black and white checkerboard screen with pixels black and white, nothing more than that. And what turns out on my CRT screen, or any CRT screen where you would run that program, is this. It creates, so this dithering pattern creates some form of misinterpretation of the signal by the CRT device, and it tricks it into thinking that there was color present in the original source when there was not. And of course, this is all related to the NTNC composite signal. I don't have the time to go into details, but basically, we found rainbows where we didn't suspect we would find rainbows. And every time you see the glitch in a PC Engine game, this is responsible for it. This is the dithering pattern that's responsible for it. I think finding rainbows unexpectedly in games is very cool. So cool that I decided to use it in the title of the book itself. As you can see, this is a texture in the lettering of the media snatcher. And more than that, we could say, okay, Carl, you found rainbows in a glitch in old video games. Okay, maybe you're over reading into this. I want to make the case that perhaps I'm not over reading here. Perhaps this was an aesthetic effect that was sought after by graphical artists at the time. Perhaps, for instance, when you're entering a new dimension, a new planet, you're landing, there's some reason, aesthetically speaking, that you might want to use such a shaky, glitchy output. And perhaps this was just another aesthetic effect that designers used in their palette back then. But if you only go through emulation and you don't reproduce all these glitchy behaviors from the CRT analog signal, you would miss part of this expressive palette that artists had back then. So moving on to the last part of the presentation. And here I'm going to show you another clip because I want to wake you up a little bit after so much discussion. So let me just show you Wonder Boy 3 Monster Lair. I'm going to share the screen. Just give me a moment. I want to optimize the output, of course. I hope some of you know this game, but sadly it's disappeared from view a little bit too. Let's look at it. So did you notice the amount of times my partner and I died in this segment? We're going to talk about real gaming and real gamers in the second portion of my presentation. Let me go back to sharing the proper screen. And just, yeah. Can you confirm that you see my full screen presentation? Yes?
Yeah.
So looking for real gamers, you'll see that this connects with ongoing debates about what games can be and should be. What you've seen is this great game, Wonder Boy 3 Monster Lair. It's the PC Engine CD-ROM version. And as you can see, it is colorful, but it is tough. It is very, very difficult. It's a platform game, run and gun, you would call it. We can also relate it to the Q-Tem-Up, as we'll do in one moment. But as you can see, the clear rating on the PC Engine Software Bible is buy it. This is one of the most fun two-player co-op games you can have on the platform, and it's an adaptation of the Westone classic from the arcade, of course. The Q-Tem-Up was a formula that emerged around 1990, around Konami's Parodius Da, and as you can see, it's very cute, it's very whimsical, but many of these games were not geared towards children. They were not easy, they were very, very difficult. In fact, some of them were among the most difficult that you could find, just like Wonder Boy Monster Lair. This is what we would call in game studies procedural irony. There's like a clash between two parts of the simulation, very cute aesthetics versus very, very tough gameplay. And so it's like the message is contradictory or even antithetical in some ways. And we could even raise the question, is it more fun to play or to watch? Because many players won't be able to perform at the level that is expected in Wonderboy 3. You pretty much need cheats if you want to go to the end without investing, many hours of rehearsal and play to get to the end. Many people actually enjoy retro gaming by procuration, like they like to engage in retro gaming by watching it instead of playing it. So already that answers our question a little bit. Like a lot of people engage in retro games by watching YouTube player, let's plays, long plays, Twitch streamers of retro games. They're so hard that sometimes apparently you like to play in your mind as you watch another person play. The ultimate irony that I want to discuss in this final section is the emergence of non-challenging gaming. And that's because it's attracting a lot of attention right now in our appreciation of games. Since the rise of the walking simulator in 2012, and with the celebration of Gone Home, which is a walking simulator, we've seen many people say that these are not real games, that it's not challenging enough. And in spite of all the accolades and all the praise that such titles might receive, we have seen a subcontinent of the gaming community call it out as bullshit gaming, not real gaming. These are not real games, to the point that we now have many accounts documenting these strong reactions. Mia Consalvo and Christopher Paul wrote this book called Real Games, What's Legitimate and What's Not in Contemporary Video Games, and importantly, who decides what's legitimate and what's not. And so according to, and not Consalvo and Paul, but according to Real Gamers, whatever that is, real games have more interaction, they have harder puzzles, they demand more of players, they take time to complete. They explained very well in the book how this was a backlash against the rise of walking simulators, so games where you can just walk through. There are some challenges, but they're very minimal compared to the genres that we all know associated with video games. Another genre that's associated with casual, non-real gaming is the visual novel. And here you have an example. It's Coffee Talk. It was a huge success in 2020. It's an Indonesian game that was translated in 12 languages that sold millions of copies on all the major contemporary platforms. So this is a thing, like what we call visual novels and walking simulators. They are encountering a huge success with many gamers who would never question themselves about the fact that, is this really a game or not? They are playing it, they are calling it games. They are buying it on Steam where it's called a game. And so there's a big clash right now about what is a real game or not, according to some gamers. I want to propose this idea to finish this presentation that non-challenging games, if you study video game history, are actually a lot more common than you think. They're everywhere to be found, and one of the best places you can find them is on the platform that I studied, the PC Engine. To be clear, we should stress first that even these very real games, the difficult games like shoot 'em ups and beat 'em ups, a lot of them had cheat modes on computers, for instance, but even on consoles, it was very easy to have an invincibility mode. In fact, the clip that I showed from Terraforming was played in invincibility mode. You might have noticed that everybody was dying, just crashing into my ship. This allowed me to go through this excellent game, to walk through the beautiful world so expertly crafted by Sid Mead, and to enjoy the totality of the game after trying to play the game quite a bit in the normal mode. Now, you could say, yeah, but this is not the real engagement with the game. Okay, but I would retort that the majority of gamers are engaging in this mode with a lot of the games that they played throughout their own gaming history. And this is certainly true if you were a Commodore 64, an Amiga, or a PC player. Like, you know so many games because so many of these games you played with an invincibility mode or unlimited lives. So in a way, walking through games is not something so strikingly new or different. We all know these games that are fun to just go through in a more relaxed state, in a less challenging mode. one of these games that can help me bring that point home is Snatcher. Snatcher is, perhaps you know it because it was created by Hideo Kojima, the same person behind the Metal Gear Solid series, and more recently Death Stranding. So Snatcher is released in 1988 on Japanese computers, and it's called a cyberpunk adventure game. But spoiler ahead, it's not a real adventure game. It is inspired by Blade Runner and Terminator and Body Snatchers. It's a wonderful game, but according to people who like real adventure games, this is not a real adventure game because it's too easy. There are not enough real puzzles in there. Now, I want to be clear. If you played it, you probably remember it feels like an adventure game because at some points you have to interview people like this dancer here in a cyberpunk future. You have to reconstruct a portrait of a criminal. And so you have to remember like what Isabella the dancer said at that moment. And it feels almost like a quiz, like you have to remember what she said, describing all the parts of the face so that you can recreate this portrait and then show it to people. This is pretty much the closest to a complicated puzzle that you would have in Snatcher. And it is pretty much a quiz more than one of the more convoluted, complicated puzzles you would find in LucasArts or Sierra Online games at the time. To be fair, the game also has some shooting mini games, where, as you can see, you have 9 squares and you have to shoot at the right time. This is a sub-component of the game, but yes, if you want to progress, you need to win these shooting contests. Now, 90% of the game, you can just click through the content. It's actually reading. You're reading Snatcher, and you're engaging with it because it's a science fiction cyberpunk universe that you like. And also because, as you might have noticed from what I've shown so far, there are beautiful ladies in Snatcher. In fact, when they released Snatcher on the PC Engine CD-ROM a few years later, Kojima and his team decided to rename it. It's not an adventure game anymore. It's a CD-romantic. They wanted to emphasize the romantic component in the game. And this links it to another lineage that is lesser known in video game history, which is Bishoujo games. And as you can see in the back cover, there's, yes, there's this SF cyberpunk fiction that is the main attraction, but there's something clearly in the lineage of Bishoujo or beautiful girl games here. There's a visual novel database out there online that documents a lot of these Bishoujo games. And again, they're associated with seduction games. It's about getting beautiful women to remove some clothes. Many of these visual novels are about seduction of beautiful girls, but not only. And on this database, you can start to see the scope, the variety of games that have been developed in what we call now a visual novel platform genre. Snatcher is in there along with 37,000 visual novels. Up to recently, we thought that this was a marginal, a side that was not very important in video game history, but yet now we have documented more than 37,000 of these games because they are, again, gamers who engage with these titles say that they're playing them, they're gamers, they're self-defining as gamers. You might think, well, okay, it's sexy seduction games. It's normal that we kind of brush this aside. Well, on my platform, they were actually called digital comics, not visual novels. The term didn't exist back then in Japan. And it turns out there are about 50 digital comics on a total of 700 games on the PC Engine. Now, this is a significant amount because it competes with dozens, like let's say, about 15 other major genres at the time. So it's a major component of the PC Engine corpus. And if we want to take this again on a macro perspective, macro historical perspective, these games were released outside of Bishoujo, outside of beautiful girl seduction games. They were associated with major franchises such as the Patlabor franchise. You might know Patlabor because it was produced by Mamoru Oshii, who is famous for the Ghost in the Shell movies. Mamoru Oshii also directed 2 Patlabor movies. It was a big mecha franchise in Japan that is also well known in Europe and North America. They created a digital comic for that, which is again a game about walking through the experience, walking through the narrative with some interactive engagement. Again, 50 games on 700 games is a lot. And if you go back to this macro historical perspective, on the 300,000 games that we have documented so far, 37,000 is also a very significant component of game history, which raises the question why most of you haven't heard about it before this presentation today. There's something happening here. To highlight the interesting nature, and will be the last part of the paper, I want to do a close reading of one of them. This is Galaxy Fräulein Yuna. It seems to be geared towards little girls, and you'll see in a moment that that's not as simple as that. It was released by Hudson Soft in 1992, and 1995 there was a follow-up. And there was also a shoot 'em up in the same media mix, in the same franchise. There was Sapphire, which is the most sought after shoot 'em up on all of the platforms. It's part of the same universe as the digital comic. This is one of the best, most technically impressive shoot 'em ups on the platform, most expensive in the retro gaming community, of course. It coexists perfectly, the digital comic and the shoot 'em up. They coexist in this PC Engine collection that was released on the PlayStation Portable. In Japan, they have no problem seeing how visual novel, digital comics, and real games can cohabit. They enjoy, in fact, going through the same fictional universe through these different genres. The PC Engine Software Bible description is very interesting here. So, overview. It's a cute idol hero anime style digital comic that spawned its own anime series. It was so popular that it spawned an anime series in Japan. As Yuna, you adventure across the galaxy, picking up companions as you go and defeating a wide selection of girls in Power Suit. It's a Power Suit game, which is very popular with boys, but it's obviously about learning to be a galaxy lady, learning to be a good girl. And it's mostly about reading how to be a good girl. Comment. So this is from Sun Team Paul, who writes, I'm a fan of digital comics, and Yuna is a pretty good one. Bear in mind, this opinion is from the viewpoint of someone who doesn't even speak or read Japanese. This game is 10 hours of reading, and some people walk through it without even understanding a word of it, because there's something else that's so engaging and engrossing. And you might have guessed it, beautiful ladies, of course, are part of the thing, but not only beautiful ladies are part of this game. I was able to play this game because fans are so enamored, they're so engrossed in this kind of software that they freely translate it. I've burned a fan translation on a CD and I played it on my PC Engine. This just happened last year. And this shows the amount of dedication that the fan community has towards this non-genre, this non-real game. The game is really, really raunchy. Would you combat these 13 Fräuleins of darkness, learning how to be a good girl along the way? And as you can see, you'll have these scenes where some of these enemies are downright BDSM ladies trying to combat you, and even talking in a very explicit way to your character. There's constant sexual innuendo between some of the characters in that game. Who is it targeting as an audience? That's a big question when you play Yuna, because it seems to be for little girls, but obviously it's not only for little girls. When you defeat the Fräuleins of Darkness, you will get these reward spectacle, these images that are borderline pornographic in some instances. This is far from the most raunchy image you can get in Galaxy Fräulein Yuna. And that indicates that the audience is, again, not simply little girls who want to talk about idols and karaoke and swimsuits and dressing. What the heck is a Fräulein anyways, is the main question asked by all of the game. And by reading through it for about 8 to 10 hours, you will get to know what a real Fräulein is. Interestingly enough, you have some combat sequences in Galaxy Fräulein Yuna that seems to mimic well-known conventions from games, from RPGs in this case. Like there seems to be a turn-based combat system in Yuna. It's pure mimicry. You can just click attack and you will win most of the time. 95% of the time you will win most of the fights. This is interesting because it's a point in time in 1992 where game conventions are used not for gaming, they're used as a storytelling prop. It's purely for the mimicry of telling a story through different means. And in this case, the prop is gaming conventions such as gaming indicators, health systems, etc., etc. Now, you might think, what's the big deal, Carl, about this? Well, in 2022, just this year, Norco was released. And Norco is a graphical adventure game, but it's not a real adventure game because the puzzles are so easy, you understand? But this game is attracting so much attention right now from all of the gaming community, even though it's not a real game. It's not a real game because you can just walk through it, you click through it, you have pleasure discovering, you have pleasure playing through the narrative, even though the challenges are minimal. And this game does exactly the same thing as Yuna 30 years before. It uses gaming conventions, heads-up displays, codes, indicators, purely as a prop to tell a story. You have no real challenge here. You don't need to master these indicators or the language of games. The language of games is used as a prop to tell a deeper story and apparently to connect you more deeply with the story. Norco is highly recommended if you haven't checked it out yet. Apparently, this has been going on for 30 years. And yet to this day, you will have people telling you these are not real games. I want to finish by highlighting something very peculiar that I found in a game that's in theory addressed at young girls. This character here, Helner. Elner is this floating little robot, but very biological looking in nature. Elner might have been inspired by Sid Mead also. This is one of Sid Mead's famous design of a personal pod vehicle. Elner seems to have a connection with this vehicle. And Elner is a mystery throughout the game. You're trying to discover what a real Fraulein is, what a real good girl is, but also who are these power suit characters that accompany you on your adventure. And at some point, Yuna asks Elner, come to think of it, Elner, what gender are you? Are you male or are you female? Interesting question. Elner responds very simply, I'm neither one. I'm not neither male nor female. You later learn in the game that all these power suits are actually extension of yourself as Yuna. They're alternative versions of yourself. They're not simply a non-binary robot. They're alternative versions of Yuna. That Yuna's power come from her ability to project herself in these in these different versions of herself. Now, perhaps I'm overreading into it again. I just wanted to point out that if you go deep into video game history, you can find some very, very interesting and fascinating things that you might not suspect otherwise. Who was the audience for Yuna? I remind you that it seems to be an idle game for a little girl that rewards proficient players with semi-pornographic images. So is the audience bishoujo perverts into science fiction who wants to be taught how to be good girls? That seems a bit nonsensical to me. And I have this hypothesis, and I'd like to develop further, that perhaps this game was trying to engage with everyone. Perhaps that was a game that was trying to address a larger spectrum of gamers. Not everyone in a sense of family-friendly entertainment as you would find on a Nintendo system back then, but again, a larger spectrum of players that play differently and that play different types of games. That's my hypothesis. In conclusion, I want to point out that the vast majority of games that I have presented today are not accessible in the miniature versions of the platform you can buy. We have about 60 games. Again, the vast majority of games that I have presented today are not included in the selection made for these miniature versions of the platform. We don't know video game history all that well now, do we? If you meet real gamers who think they know what real games are or should be, please send them my way. I'm looking for people to play the follow-up to Galaxy Fraulein Yuna with me. Thank you very much for your attention, and I'm looking forward to the questions.
Thank you very much. What a roller coaster of emotion. I was discussing with Ian here. We got, oh my God, you saw that. And it was like very interesting and very good actually for us as software engineers and and to have like a different look on video games, like more historical, more qualitative look, I would say. Just on before I open to question, when you mentioned the comment that the guys played the whole game without knowing Japanese, that feels like home, because back in Brazil, when we didn't have access to easy to the games, we were playing Parasite Eve 2 in Japanese, and we played the whole game in Japanese, and we finished over and over because the gameplay was fun. Everything was fun, and there is a sequence in the game that has specifically asking question, and we have to ask questions in Japanese, and we don't know. Then we have to try and error every single one of the word because we didn't know.
So you didn't have a cheat mode. You just played through the combat or RPG combat sequences, and that's still playable even though it's in Japanese, because it's the same. Attack, defend, magic spell, etc. But some parts you really had a branching structure that you had to navigate in Japanese to try to go forward.
Yeah, but interesting about the history is that we invented the history in our minds because we didn't know what was happening. Then we had the cutscenes, and then we have the Japanese text, and maybe that is happening like this. And in the end, we have a whole different story in our minds. And later on, when I play in English, and then, so that's what's happening. The same for Final Fantasy IX and many other games. So it's so open to questions. Why not?
I'm sure your histories were better than the original.
We are open to question. Who wants to start?
Well, actually, maybe I have more like to hear from you, Carl. What do you think about interactive fictions? That was pretty popular, right, in the 80s and the 90s. Those games that were more like
they are still my students in game history classes. Most of them have not heard about the great Zork Underground Empire and such. But Infocom released dozens of text adventures and sold millions of copies. And it's interesting because perhaps John can help us here. He's working on an old textual adventure game, because it's the same thing. Some of them were more gamey because you had complicated puzzles. You needed to find items and use them at the right moment. You needed to solve a puzzle at many instances in the game. But other games were more about reading through and discovering the fiction. And I would love to jump back into these dozens of titles, because I'm sure you find a similar variety of gaming experiences. But yes, definitely I think we should go back to this corpus of interactive fiction.
Mm-hmm. Thank you. Yeah. And so you said nowadays people seem to prefer like more gamey games, but maybe I misunderstood, because Christian was telling me that on Steam actually there are a lot of interactive fiction or dynamic comics, or I don't know you would call them. So this is actually quite popular still, but maybe it's also because it's more popular in Japan than in maybe Americas.
So this is a stereotype that it's more of a Japanese thing, and for a long time we thought that these visual novels or bishoujo games or otome games were mostly popular in Japan. But this is not true anymore, because we've seen the international success of some of these titles. They're released on Steam. They're released on all the major platforms like the Xbox or PlayStation outside of Japan now. They are translated. They are produced by teams all around the world, because it's one of the genres of games that you can easily produce. It's easier to program than a 3D model, for instance. I think to answer the first part of the question, you would see since Gamergate, I guess, or since the popularity of walking simulators about 10 years ago, there was a backlash in parts of the gaming community that were outraged that we would consider this to be a type of video game. They lost, and I don't know if they're still very strong. I can still find some people in my classroom that think that games should always have these very high challenges, very demanding challenges, be it sensory motor or resolution, cognitive skills. But it seems to be, to me, that it's a minority of people now that are becoming less vocal. They used to be very vocal about calling out these, unreal games. I like to call them unreal games because it sounds cooler than not real games. There was a lot of backlash. There was a lot of calling out, as Consalvo and Paul point out. It is also related to the presence of a greater diversity of audiences for visual novels and these genres, because a lot of queer folks, for instance, use this format to represent their reality. This was the case with Gone Home. Gone Home has some LGBTQ themes in it. And so the backlash is against the format of the game, but also against the content of the game to some extent. I'm not saying there's no argument to be made. As you can see, I'm a game historian. I like to study the systems of games. My point is just that, well, if millions of people are walking through or clicking through these visual novels and calling it games and saying that they're playing it, at the end of Norco, which is again a walk-through, play-through, click-through, it says, thank you for playing. As a historian, I have no interest of going to these people like, no, this is not a real game. This is pointless. There's already millions of people who have embraced this format. It's just that the backlash coming from some parts of the gamer community is still present. And again, if you meet these gamers, please send them my way, because I will have a great conversation with them, showing to them that this has been present in game history for the longest time. And everybody could see these genres cohabiting and even dialoguing, like Yuna as a shoot 'em up and as a digital comic. These genres can cohabit and be part of the same media mix, and people have fun entering these various formats to discover the fiction of Yuna. So I think, sadly, now in contemporary culture, some gamers might be isolated and stuck with the same community who build these fake ideas of what is a walking simulator, what is a visual novel. And I think we have to that's why I'm doing this presentation, and that's why I'm doing this argument in many other places. I want to make it clear that no, this is not new. And what you think is not a real game has existed for a long time, since the beginning of game history. And John is writing a book on amnesia, right, John? And would you say that, well, it's not completely click-through, right? There are some puzzle-ish elements in it.
It is. So, Amnesia is a game which is a text adventure, but yes, it's very much on rails. So it's very clear playing that you are being guided with a very firm hand in a certain direction.
And it doesn't mean it's not a game. It just means that sometimes you will feel like it's an adventure game. Just like Norco and Yuna, when you have a branching structure, you're thinking, okay, maybe I have to find an item. Maybe there's a puzzle. Maybe there's a good direction. There's a bad direction. So sometimes your mind will go into a clear resolution mode or puzzle solving mode. But if you just click through every option, the game is non-challenging enough that you will be able to progress most of the time.
Mm-hmm.
And Amnesia was released by, it was an Infocom title, John?
Electronic Arts.
Electronic Arts.
A surprisingly late all-text adventure.
Which year?
86 was the original release.
So, but Infocom re-released some of their titles up to the 1990s, early 1990s. There was still an audience for written interactive fiction.
Mm-hmm. Although to speak to what Cristiano was saying earlier, I mean, you think about the early text adventures where you didn't have that point and click interface. There were really two games going on. There was the game itself as presented by the text, and then there was the additional game of figuring out what on earth the vocabulary was. And even if you spoke the language, that could still be quite a challenge at times.
Yeah.
They started eventually to put in the manuals, you would get the most common verbs that you can put in the textual parser. But yes, the first one, they said that it understands all of the English language, which was, of course, a big lie. And it was a puzzle in itself, trying to figure out which text you can use.
Yeah. So I just want to add to this conversation. Like when I read Doom, Masters of Doom, the book, I think they mentioned that because they wanted to do the FPS, right? FPS, let's shoot and kill and that's it. Go forward. No history, no nothing. And the Mist, correct me if I'm wrong. The Mist was the game. the Myst game is more or less in that way, that you just like, you have puzzles to go, but it's more like screens, like static screens. And I think one of the developers, I'm not sure if it's John Carmack or Romero, said this is not a game. He said this is not a game. This is I don't know what they call it, but Doom is the game. The other one is not game. I missed that. Reminds me when you were mentioning. Reminds me that.
Of course, and then the two Johns and many game developers are playing this debate also. And I'm not saying they're toxic in the way they conduct this debate, but yes, after in some storybooks, John Carmack and John Romero will brag about how the future belongs to 3D programmers and that these adventure games were something of the past. And irony being the main mode of history, if you ask me. Now, these adventure games and even these less challenging adventure games are making a big comeback nowadays. Like Norco is receiving, breakthrough reviews, major accolades from. It even received the game prize at the Tribeca Film Festival. Like Tribeca now has a game award, and Norco won the best video game at Tribeca Film Festival. So we might agree that, yeah, 3D programming requires more skill from programmers. And so, of course, I understand what they mean when they say the future is there. But it doesn't mean that these other genres, that these other ludic forms are not worthy of progressing in time and in history also.
Yeah.
I have one question for Carl. Maybe Carl, you talk about a lot about history, but how could you imagine that the software engineering community and software developers could support more the people as you and your research teams to collect data and how to provide metadata to support this history endeavor, to preserve the history of video game as art and as piece of technology? How kind of structure maybe you could push the development community to support your work?
Well, thank you very much for this question, because that's the beauty of having these interactions with people outside of the discipline, is that everybody can help to do better when it comes to game history. And John's work also already shows you a little bit of what we can do in terms of inspecting code and finding, code repetition and code reuse. If you want to know specifically what I would need, right now I'm trying to encode 2,000 games selected by communities from around the world, because we want to make sure everybody has a say in this large corpora, this large canon of games. We will encode that with an analytical system. Like we have about 30 concepts. I've shown a clip, I've shown an image of what we're doing. Basically, we take a lot of games, we encode them with the same metadata. I would need programmers who are able to program AI that looks for patterns into all this data. Because I don't have the skills, I don't have the skill set, and I don't know anybody who does. But basically, we'll have 2,000 games encoded with a stable framework, and we will be able to visualize the data. Like we'll be able to click on a concept and see when it's more prevalent in history. But what about the clustering of concepts? And I'm sure that if we put 3,000, 4,000, 10,000 games into a system like that and have some form of AI help us, assist us in interpreting the clustering of data and concept, we could find great stuff about game history and build periods, based on this data collection, and not based on what John Carmack said about the future, or not based on your personal history of games. It's all about developing a synoptic perspective about video game history, and it can only be done with the help of computer scientists, programmers, and engineers at this point.
Absolutely.
Perhaps I can show you, Fabio, very quickly. I'm not sure if I put it in an extra slide somewhere. Yes, it's at the end. Yes, I can share you. Okay, just give me 1 second, because this is exactly what we're talking about.
Because I think it's a great opportunity for us to collaborate in order to support this great work?
So this is what we're doing right now. Like we're starting to analyze, like again, the basic is that we encode a corpus of game with the same analytical system. And then we try to visualize data in history. And here you can see one example of clustering that we find. Like we found that often in games, when you manage resources, you can have a mouse or another, like a Wiimote, a corporeal manipulation interface, and that you have some form of action mapping. I don't have the time to go into all the details, but basically we're seeing that for certain categories of action, certain types of interface and certain types of mapping reoccur more often. It would be great to have AI, a program, help us detect the clustering once we have the thousands and thousands of games in our system. That would be, something that I don't have the skills to do, and we would need someone who would have the time to get acquainted with our system and build the custom code to analyze the clustering effect throughout history.
Sure, but my question is also for the future projects. Imagine the new project that people are developing. What kind of a structure maybe also you could starting to provide for?
So there's possibilities into and some scholars in game studies are already conducting big data analysis. So let's say you take the 300,000 games on Moby Games or the 37,000 games on the visual novel database. You study their metadata structure, and then you try to see what clustering effects you can detect, at what point in history do they become more prevalent. Now, the obvious limitation of that system is that thousands of people have fed Moby Games the entries for 300,000 games. Do they apply the concepts and the metadata in the same way? No. I've tried doing it with scholars for many years, and even with 30 concepts, it's very hard to have consistent coding. There's no way that thousands of contributors can code metadata in the same way. There's no interjudge validation. This is what we're trying to do right now. We're trying to do interjudge validation for many of our tools. But I would still be very, very curious to inspect the visual novel database, because they have some metadata that's very reliable. For instance, I told you about this bias towards beautiful girl games. This corpus is probably neglected because it's associated with porn or erotic games for young otaku male heterosexuals. Well, actually, if you dig into the database, the visual novel database, you will see that there are some early titles in the 90s already that cater to bisexual people or to even homosexual people. So I would love to have a data inspection tool to come up with interpretation of the metadata that they have on the visual novel database. I'd see in the future, that's what I like to do directly, to collaborate with programmers to make this data speak a bit more clearly than it does right now.
May I offer a slightly different take on Fabio's question? So my suggestion would be, speaking as someone who's had to go back and try and find code or reverse engineer binary code or has done some archival work, save everything. Because you don't know whether something as trivial as business records or scrap bits of paper that you've scribbled notes on when you're doing development are going to be useful for a researcher 40 years from now. So earlier this summer, a colleague and I went to the Strong National Museum of Play, and we're looking through, among other things, the papers of Carol Shaw, who did River Raid, and she had kept all her dev notes, so bits of debugging, scraps of concepts on paper that never saw the light of day. And so it can really give a deep insight into the development process that we wouldn't otherwise be able to get. Because, of course, you can imagine that over the process of time, I mean, I can barely remember what I had to eat last week, and asking someone about, gosh, what did you do 40 years ago? It's going to be a challenge to get an accurate recollection of that. And so, yeah, save everything. And the other thing, too, is because, of course, internally, you always think of yourself as young in your own personal narrative. You don't realize that the code that you wrote 30, 40 years ago is now something potentially of historical interest. And I think that's part of the hurdle, is that people who wrote this code don't necessarily realize that, and don't necessarily think that even though they have advanced in their careers and their programming style, and maybe they aren't as proud of the stuff they wrote when they were 20 years old, it's still good to see in that original form to get a sense of how they have developed, how they did develop back then.
Absolutely.
Yeah, that's so true. Even today, to find good documentation, well, that's impossible to find a good documentation on how the game was built. Well, it's so hard to find the source code for a game so that we can study and find the nature of game industries more closer. So it's very hard for us to. So I really like the idea of digging into documentation and information. Anything else, guys? Or
yeah, maybe we can keep the conversation offline, because I think we have clear common interests. And I'm gonna read the paper that you wrote, John and Carl.
Yeah.
I'm very curious to learn more about it. And then maybe we can collaborate on some future analysis or future. I mean, there are so many games, and of course, Carl, but I think we have to study Amiga games.
Oh,
would you believe that we're barely entering, barely any Commodore 64 games are present in our historical imagination, or Amiga games for that matter. There were thousands and thousands of games released on these platforms. The only pretension I have of being a video game historian is that because the age of 5 and 10, I played cracked copies of hundreds and hundreds of games on the Commodore 64. And that's where the interest for all that you could do, the expressive potential of games appeared very clearly, very early on. And thanks to the crackers and the pirates, I had access, and I could walk through some of them, and I could play them, others in a full antagonistic mode in other cases. But yes, we barely know these 300,000 games in game history, and there's probably more than that. We definitely have to kick off and do some more research.
It's interesting actually how crackers, I mean, at the time were evil, right? Seen as evil, but thanks to them, we have copies that we can play still today. Without them, many games would have been lost forever, because they would have been unplayable today, or just lost. I mean, purely completely lost, because the disc become unreadable. And so, yeah.
The reason John was able to conduct this analysis of code reuse was because we have access to, in the end, we have nearly 2,000 image ROMs of the cartridges released on the 2600. And yes, so thanks to all these people doing work in the shadows, and people like John and I have to say in our papers, like, yes, we are doing this under fair dealing or fair use, because this is not exactly legit or legal, but if we didn't have that, we could do so little, basically.
Actually, that's how did you do? Like, you just put a disclaimer, or did you have to go through some ethical?
There was some disclaimer in the paper directly, John. That's how we proceeded, right? Yeah.
Because I guess, I mean, Atari is still around, right? So technically, could they come after you, or could they come after anyone? I mean, anyone who's playing those games?
We're not responsible for creating the ROM, the dark archives, and any of that. There are a few cases where they went after. Nintendo did have a very intimidating lawsuit at someone hosting a ROM site in the United States, like 13 million lawsuit, and they won. And it was just to scare other people into doing this kind of work. But for scholars, I'm not afraid. I'm never, and that's why I thank people who do this work, and perhaps Nintendo and other corporations will realize that all these people are doing their work, which is evaluating their production as heritage and as history. And perhaps if they realize the value of that at some point, they will stop being so, trying to scare us off from this corpus.
Maybe become more cooperative. Little bit.
Oh, I hardly believe in that.
We can dream. We can dream.
Yeah, exactly. Well, thank you again. Thank you very much. Thank you everyone for attending and everything. So I think we can close. Thank you again, Carl, also for your keynote. It was very, very interesting.
Thanks again for the invitation.
We can meet one of these days, because we still have, I mean, we had this proposal, right, that was rejected, but we can still also keep on working.
We're supposed to work on VR. Like I work on history or VR. I work in the past and the future. So looking forward to discussing other projects with you. Yeah.
Perfect. Great. Thank you so much.
So
thank you.
just for
care,
closing, thank you, Carl. Yeah, I hope that everyone enjoyed the workshop and this open mind talk. And I think that it's important that this is a community that you are trying to create. And I hope that next year you can continue to progress in order to grow up this research and grow up this domain. And I hope that everyone enjoyed that. You continue in Discord, the community are there. And also we will send a small survey for people to share the feedback and collaborations and how can you improve for the next edition. I hope to see you everyone in the next. Thank you everyone. It's listening and watching on YouTube, and see you in the next opportunity. Thank you, Carl. Thank you, Chris, and Ian, and everyone.
Bye.
Bye-bye. Thank you again. Congrats for great work. And stopping the recording and